Can you see my screen?
Yep.
Fantastic. Right. So for the longest time, we've all encountered computers in many different ways. But for most people on this call, perhaps you use your computer on a day-to-day basis and you interact directly with folders, with images and files. You use all the many different functions on your computer directly, but so this would be what we call the GUI, or the graphic user interface. So what you can see, touch, the tangible part of your computer that's visible. So when you would click on a folder, for instance, to find something, that's you engaging with the graphic user interface. However, it might be the intuitive way to use the computer, but there's a faster way to get things done and automate processes, because I'm sure none of us here like repeating one process a million times. And that's why we have the shell. And so the shell is essentially a program where you can type certain commands, and some of all these terms will start to make more sense as we progress. You can type commands into the shell, and it's possible to do a bunch of things. You would get so proficient using the shell that you wouldn't even want to use your computer the usual way anymore. And the most popular Unix shell would be what we call bash, B-A-S-H. I'm going to just put that in the chat as soon as I can find the chat. So we call this bash, and it's the born-again shell. And it's not the born-again shell because it repented, but the person who created this shell is Stephen Byrne, and that's why it's called the born-again shell. I will walk you through getting this set up in your own computer, but just to give some context to why we even need bash in the first place. And so there might be repetitive tasks that you have to do, and you wouldn't want to do this using your own human effort. And so to open up a terminal in your computer, you could, I'm going to share my screen and show you how I would do that. Depending on whether you're using a Windows or Mac or Linux, the steps might look a bit different for you. But if you're on a Windows, you could get the Git bash installed. Git bash allows you to use both Git, which we'll be covering later today, and the Unix shell together in one. Or if you're on a Mac OS, you could just go to Spotlight and search for terminal, or run. My favorite way to do it is actually to just type command and spacebar, and you can search terminal. So once you search terminal, you can click on that, and you should have something like what's shown on the screen right now. James, I'm going to ask you to please keep an eye on the chat in case someone is struggling or needs a bit of help.
Oh yeah, I'll keep an eye on it.
Thank you. And I'll pause here to give people time to actually open up their terminals.
Hello, ma'am.
Yes, please.
What if you are using Linux?
Yes, so there are instructions. That's a great question, by the way, Obi. If you're using a Linux system, there's already a default Unix shell in it, and it's most likely going to be Bash, that born again shell, which we mentioned. And so if you run a regular GNOME terminal, you would have Bash there. Obi, does that help?
Yeah, it does help, but I don't. Could you explicitly explain that bash? Is it regarded as a folder, or you just say, as a lay person, I don't understand bash. What can I say bash is all about?
Okay, I see James put in the download instructions page. So as far as the features of Bash go, we will cover that much later, but it's a kind of Unix shell. And as we progress in the lesson, you'll get to understand what we mean by a kind of Unix shell. But I suppose the first step would actually be for you to try to get that opened in your computer. If you go to this link that James has provided, at the very bottom of this page, you would find instructions specifically for the Linux OS. And do let us know if you get stuck anywhere. I'm going to ask you to please put a green check mark if you've successfully opened the terminal on your end. Okay, I see Nancy has that set up. If you have some trouble getting that done, to let us know, you can give us a thumbs up. The check mark will be found in the reactions bar. So if you look at your Zoom, there's a button to raise your hand. Just next to that, you would find the green check mark, or you can just tell us in the chat that you've successfully opened the terminal. Wait for a couple seconds more because it's important to have that open and follow along so you get the best out of the lesson. Awesome. Nice. OB has that open, TG as well. So if anyone is struggling to do this, do let us know. We have instructors here and helpers who would put you through. Nice. Sylvester has that as well. Awesome. All right. So we're going to just move on to the very first episode, and in hopes that everyone has opened up their terminal at this point, or if you haven't, you can always ask for help in the chat. Excuse me. Pardon me. Yeah. And so I'm just going to quickly confirm that you can still see my shell.
We could see, but now I can't see your sharing anymore.
Okay, I'm going to reshare that. And now?
Yep, I can see that.
And
Yep.
size-wise, does it look good for everyone? Is the
Yeah, I
font
can see it.
awesome? All right, we will head straight into the next part. So we're going to try and answer a few questions. For instance, what even is a command shell and why would anybody need to use one? And we will try to explain how the shell relates to every other component of your computer, your keyboard, your screen, the operating system. We would also try and explain when and why it is appropriate to use a command line interface as opposed to that graphic user interface that we described earlier, that GUI, the parts that you can see, right? And as I mentioned earlier, humans most often use their computers through click, drag and drop, upload, using the parts of the computer that you can see. But for instance, if you needed to do a task like the one I'm about to describe, if you needed to open 6,000 files, for instance, and copy out the third line of those files, copy out the third line and paste them into a single file, that would mean manually clicking on every single one of those files, going to the third line, copy, and then paste into the new file. Open the next file till you get to 5,999 if you make it that far, and then to the 6,001. And you can already see how there's so much margin for error if you decided to do it this way. However, you can use your Unix shell to execute this same task in a shorter time period by writing these commands or scripts. And I will explain what that means. So the shell is essentially a program that allows you, the user, to type in commands. And these commands will invoke certain functions. And it can be something as simple as creating a new folder on your computer, or something as grand as climate modeling software. You see how worlds apart that sounds, but this same thing can give you the power to do that. And hopefully you're already getting excited about learning Bash or this specific Unix tool. And with all your terminals open, we will explain a few terms. So in the human language, if I said something like the mango bring, that might make sense to some extent, but there's a limitation to how much sense you can make when you use few words in English language or in your local dialect. However, with very few words or commands, you can do so much in Unix. This is one of the biggest advantages of using the command line. And so right here in your open terminal, you should already see this aspects. So your terminal probably already looks like this. All I did was to open my terminal, and to set this up specifically for Bash, I'm going to type in here echo shell. And this does show me that I'm in the right place. I'm where I should be. And so if you could look at your computer now, and I would recommend that you not worry too much about these details behind this percentage. And you might wonder why I have a percentage, and you probably have something that looks like a dollar sign. Don't worry, we're on different operating systems. It will still work as it should. And so in your, yeah, I see a green check mark from Nancy that hasn't gone down yet. Yeah. So in your own terminal, you should see a dollar sign like this. You should already see that dollar sign. And that dollar sign is basically telling you that you can deliver a prompt or a command to your terminal, that's your Unix shell. That's what that dollar sign tells you, meaning you don't have to type it anytime you need to make a command. It's already there. So what you type in would be your command itself. And we've been saying command, command, command. Let's experiment with the commands and see what that looks like. So the very first command we're going to be learning today would be ls. L, yeah, in lowercase, ls. And lucky for us, most of the commands would be easy to remember because they are just a short form of what they actually mean. So ls would be list or listing. And to run that command, you press enter, or if you're on a Mac, you could press return. I will pause and be sure that this worked as intended for everyone else. So what you should see is a list of all the directories or folders at the root. And that brings me to a quick explanation of this part. So this is just the name of my computer. What profile I've created on the computer. Depth for you, it might be something else. And my host is Mac. And if ls has worked the way it's supposed to, I'd like to see those green check marks, please. Or reactions in the chat. Ah, it worked for Trevor. That's nice. And for Sylvester. Remember, if you struggle with any parts of this, please just leave a message in the chat. Nice, it worked for Nancy. And someone will help you out. Awesome. So this lists out all the folders right where I've opened my, yes, Obi, you typed echo shell in the Linux and it gave bin bash. Yes, that's exactly what you should see if you're in the right place. All right. And so it's outputs, applications, desktop, documents, downloads. These are all the folders at the root of my computer. Nice. And if you accidentally type the wrong command, maybe you misspelled it, it's going to scream at you and say, yeah, I don't recognize that command. And it's a good way to know whether you've made a mistake. So for instance, if we say KS and click enter or return, shell is saying command not found. It's saying, I don't recognize KS, right? So we're going to look at a case study, so to speak, of a marine biologist called Neil. And they've just returned from a 6-month survey of the North Pacific Gary. I'm not sure how that word is pronounced, but just imagine that a marine biologist has gone to Alaska. That's easier to pronounce. And they've uncovered so many new discoveries. But now having discoveries can be a blessing and a curse. So she has 1,520 samples to run through an assay machine to measure the relative abundance of 300 different proteins. And she needs to run these 1,520 files through an imaginary program that we'll be calling goostats.sh. I'm going to type that here just so you see what, we don't need that as a command, but I'm just going to type it here so you see what we're talking about. So this marine biologist has to run all of that 1,520 files through this shell program. You can already see that it's a shell program because it's got the .sh extension. So when you see this .sh, it shows you that that's a shell script. And in addition to this particular task that already seems so cumbersome, so hard, she needs to come up with a paper about her findings in a short time period, just at the end of the month. If she wants to run this file by hand through the 1,520, she would need to run each file one by one, one by one. So GoStat, if it takes 30 seconds to run each file, imagine having to do that for 1,520 different files. That would take at least 12 hours of Nelly's attention. And so with a shell, she can assign her computer this particular task and say, hey, do this. And she can focus on the more human side of things, which is writing that paper. So over the next few lessons, we're going to explore the different ways that Nell can do this 2 tasks, and specifically looking at how she can use the power of the Unix shell to achieve her goals in a shorter time. She would essentially need to create a loop to go over all of the data that she's collected. And this loop, she doesn't need to interfere. The computer does all these repetitive tasks and she can breathe easily. And as a bonus, once she has her pipeline, and all of these terms will make more sense as we go deeper into the lesson, she will be able to use it again to collect more data. So our goal here is to show you how you can navigate through files and directories, how you can create a new file and directory. Remember that directory is what you would call a folder, and how you can check the length of a file and commands that you can run together, how you can retrieve a set of files, how you can iterate or run over files or loop over files, and how you can run a shell script that contains a pipeline. So at this point, we've already established that a shell is a program, right? It's a program, and the primary purpose of the program is to read commands and run programs. So the shell is a program and it allows you to run other programs. And in this lesson, we're going to be using bash, which is the default shell in many of the Unix implementations. And we've all confirmed that we've opened up our terminal, and we will tell you why this Unix shell is of a bigger advantage than your regular double tapping or clicking or using your mouse many different times. I'm going to pause here and ask whether, what questions do we have so far about the Unix shell, bash, about the command ls. You can type them in the chat or just let us know. So the focus for the next few minutes would be how to navigate files and folders. This is just a black a black box. It doesn't look like it can do anything. So how could I possibly move around in my computer? How can I see what files I have? How can I specify the location of a file or a directory on my computer? So we will look at the similarities between a file and a directory. We will look at how to translate absolute and relative paths. Let's see. Yes. Oh, that's a good question. Trevor is asking whether there's a difference between your root directory and your current directory. That's a very good question. So the root directory is at the very base of your computer. It's not within any specific folder. It's just at the, so if you pictured your file folder structure as a tree, right? As a tree, from the root, you can look upwards and see the different branches, which would be like folders and files within folders and files within files. And you get more specific as you enter within those branches. But the root is at the very base of the computer, which is why when you look at mine right now, which is at the root, when we did an ls, we saw all of the applications, the desktop folder, documents, libraries, all of this would be at the base. So anything you just leave at the home screen, that's a gross oversimplification, but I'm hoping that you get the idea of that root directory. Moreover, the current directory would be where you're situated in at the present moment. For me, I'm at the root, which also happens to be my current directory. But if I were to move into this desktop, it would be different. So this would now be my current directory. So where you are, what folder you're looking at every point in time, that's the current folder, as opposed to the root folder, the root, which is where you'd find all other folders. So it's like the big parent of everything else on your computer. And I hope to some extent that that helped Trevor. Awesome. Thank you. All right. So our computer has a way of managing all the many, many different folders that it has. And this is what we would call the file system. File system. And it's how we organize our data into different files or folders. In 5 minutes, I'm going to ask a question related to files, folders, and directories. So do keep that in mind. A file we would soon see is just a single one, just a single file. Oh, it sounds I make it sound weird when I say a file is a file. But yeah, but a directory we could also call a folder, which then houses either other folders or files. And there are several commands that we can use to create files or folders, or to rename them, delete them. And I'll actually say here that you don't need to memorize these commands. It's handy if you keep them in mind, but in personal experience, I found that by using these commands, you naturally begin to store the ones that are the most important to you. And so if you need to search Google in the meantime to find, oh, how do I delete a folder? That's completely fine. When you do it many times by muscle memory, automatically it will stick. So don't worry too much about memorizing. Just try to understand the concepts. And so for us to find out where we are currently, we use a command pwd. Remember how I mentioned that ls, for instance, is easy to remember because it's list or listing, like this is. So rather than tell your computer, list the current files here, you just say simply ls. And now we introduce this command pwd. It means print the working directory. So tell us essentially where we are right now. And if you type pwd and say enter, it says users debs. So I'm just at the root. Remember what we said about root? There are some users in this computer, this machine, and I'm currently looking at the user debs. Yeah. And so I will pause and ask you to tell me what it's outputted in your own computer. Brilliant. Home Trevor. And thank you, James. Just to reiterate what James has said, if you're stuck, you can definitely go to a separate room and get help. Yeah, I see it worked for Trevor. I wonder whether it worked for anyone else. Nice, Obi. That's very nice. Nice, it worked for Sylvester as well. That's good. So it shows your current working directory, and now you're in the home directory of Debs or the home directory of Trevor, etc. And a quick note is that this home directory would look different on the different operating systems. If you look at mine, it might look slightly different from what you see on yours. So on Windows, mine should actually say home debs, right? On Windows. Similarly, it might say, so if you're using a Windows, you might see this instead, right? But it's all one and the same thing. So looking at that case study of the marine biologist, we're just going to assume, we didn't look at her computer, but we're just going to assume that she might have the home directory that looks like mine. And within this, there would be some sub files, maybe a bin, a data folder, a folder that says users or temp, so a temporary storage, And this is all assumptions. We don't know Nelly that well to know what her files look like. So we want to take a moment to explain what this very important slash means, right? So users slash Debs or users slash Trevor. We want to know if that slash does have an implication on our ability to use the shell or what we can use it for. So users would be the first part of the name, and it has to be separated from the actual name of the user by a slash. So for instance, we can't have users Debs. That absolutely makes no sense. This would get so complicated if, for instance, within the Debs directory, we want to go to desktop, and now desktop looks like this. It could get so complicated very fast. So we use that slash for one to have like a visual distinction between each of the places where we're located. But it goes way beyond that, right? So the slash, it's placed in front of every file or every directory name. So the slash in itself indicates a root directory. You see that there's nothing behind here. There's nothing behind it. So that character just shows you that this is where the root begins, right? And if you see it within the rest of, let me type this out. Users, Debs. So right here, this slash is just indicating the root, the very last place where you are. But if it comes up in the middle of other parts, we will explain parts in detail, then it's just used as a separator. So we would run that ls command again, ls, and what should this command output? In a couple of seconds, what should ls output for us? As soon as the rudiments are ingrained into you, then we could pick up the pace, but we need to be sure that we understand the basics first. What would the ls command output? Awesome. It would list the files or folders. Nice, very nice. So that ls shows us all the files again. And it prints out the names of both the files and the folders. And I did say that I will ask a question about this. What else can we call a file? What else can we call a folder, rather? What other name can we use for the word folder? Well, this everyone is on fire today. Awesome. Yeah, we can say folder or directory. This is so nice. All right. But now we can ask these command to list something specific, right? We can ask it to list, maybe list only the files or list only the folders. Let me create some more room at the bottom here. All right. And so that brings us to the idea of options. So we have commands like ls, but within those commands, we also have options to make those commands do specific things, using one command. So for instance, we know that ls would list, but if we wanted to list not folders, but files, there would be a way to do that, adding an option. And anytime we need to add an option to a command, we use this. That's a regular hyphen. And then we add whatever option we need to use. So we can use ls f, and I'm going to ask you to do ls option f and see what that yields for you. What difference did LSF make? For me, this is LSF. And what LSF did was to sort of create pointers for us to show us which ones are home directories. And a home directory would be the main folder that contains other items. So if you look at this, applications now has the slash in front of it to indicate that it's a home directory. It's a home folder housing other things. But if you look here, this doesn't have that slash in front. Why might that be? What ideas do we have about this? Remember, we're saying LSF shows us what folders contain other things by adding the slash to the front to indicate that these are really folders that have something else. So why would I won't say what it is, but why would untitled.ipnb, which is a Pi notebook thing, why doesn't it have the slash in front? Let's see. Nice. So Trevor says it's a file. Exactly. So it's a Python notebook file. And as such, it won't have that label on it. It is a single file. Indeed. Okay, that's right. So this command basically says, help me out here. Put a label on everything that's a folder, a home folder containing other things. So that helps you know which ones are files and which ones are folders. Good. And at this point, we have so many commands that we've used. Let's see. Obi says for them that it types the folder and files under it. Nice. So it showed you what folders there were, but then also added the files. Nice. We should trade computers. So if your screen gets too clustered, like mine, you could easily clear your terminal. And lucky for us, it's another command that's very explicit and does exactly what you tell it to do. So I'm going to click on clear and let's see what happens. And just like that, all the things that we had typed, it's gone. But you still have those commands stored in the terminal's memory. My mind was blown when I heard that the Unix shell could store up to, I think, 1,000 or 10,000 of these commands, previous commands, and you can still access them. I was very pleased. And to go back to the old commands, you would use the up arrow button on your computer or the down to So I just pressed the up arrow key, and if I keep doing that, it goes to all the previous commands, and that's the end of it. If I pressed on the down arrow, it comes back this way. So that's a very easy and convenient way to get your previous commands. If you don't feel like you want to type clear again, you can just go back and use the clear command. So go back and then hit enter. All right, so if you wanted some help with all of these many commands, the ls command has so many options, meaning things that you could use it for. And if you wanted to know what's the content of this ls command was, you can use the flag help. And when I do enter here, oh, behold my first error. This is a sign that I've never asked my Mac for help. Apparently the ls help command is not recognized here. I'm not sure why that is. I'm going to ask my Windows and Linux users. So it works on many Windows and is recognized in Linux. For some reason, Mac OS has refused to recognize the ls command. Let me see. So on a Linux or Mac, apparently, let's see, there's a message in the chat. Yeah, works in Linux. Nice. So on the Mac OS, apparently we can read an entire manual for the ls command if we type man ls. Hopefully this works. I'm crossing my fingers. You can't see me. Yeah, so this gives you a screen filled with so much text about the ls command. And if you wanted to know all the many things that this particular command can do, yeah, this is where you'd find it. So the one we've used is the F, and it displays a slash immediately after a path name that is a directory. Yeah, an asterisk if it's an executable, and an @ after a symbolic link, and equals after each socket. So this is way too much information. And it continues. Yeah. All right. My Mac is screaming at me. It won't let, oh, maybe I should silence my Mac so you don't have to hear all the yelling it's yelling at me. I'm going to close my terminal and then open. I can't seem to find my way out of it. I would make a joke about Vim, but Instructor does need help getting out of a bad command. Save me, James.
Is it a Vim window that's open? Maybe it's
No.
it
Not.
or this.
Okay, yeah. So Q
Yeah.
still works to get it. Nice. Okay. Crisis averted. Thank you, James.
You also did so list help isn't working for me either in my git bash
Yeah.
in Windows, but the next thing in the lesson is how to use man, which you've just
Yeah.
authentically demonstrated in a real life situation. So that's a perfect demo of that.
Yes. And so yeah, when ls help doesn't help, we can use man ls and get stuck with our own terminal. I will not risk entering anymore. But yeah, to exit, I just used Q, the letter Q on my keyboard to exit. And yeah, we're back. And hopefully man ls or ls help worked for people on the call. Yeah, I'm going to pause and say, what questions do we have? Right. Let's see. All right, Trevor says so far so good. That's a relief. So there aren't any questions at the moment. If you think of something, please feel free to put that in the chat. Yeah. So with all the options you've seen when we did man ls, you could experiment to see what other things you can do with your ls command. So we would progress to exploring other directories. So if we come back here and we do the ls list command F and then say desktop, so this outputs every single thing. I hope I don't have anything too embarrassing on my desktop, but this lists out every single thing on the desktop. So a file, a PDF file, a folder. Remember, this is a folder because of this slash in front. PDF files, more PDFs, more PNG files. Do not ask why there are so many screenshots and all of this. And right here, this is something very important that we will come to, Shell Novice main. So this lesson is hosted on the platform that we call
It's 9 hours.
Thank you, computer person. So the lesson we're going through now is hosted on the platform called GitHub that allows you to store your files. We will get into that much later. And I will try to go into this file because we do need it for the lesson. So to navigate into a file, I'm sorry, my router is acting up. Just quickly checking that people can still hear me.
Yeah, we can still hear and everything's been coming through.
Fantastic. Thank you so much. Yeah. All right. So we want to go into a folder called desktop and try and access this shell novice main so that we can get the specific shell lesson that James, I'm just quickly going to check with you whether participants were supposed to download this ahead of time so I can provide a link to that.
Is this for the data set?
Yeah.
The exercise data, it was part of the setup instructions I saw, but yeah, we can check whether people have downloaded.
Okay.
I've also downloaded the same as you, I think, which is the thing that has the exercise data and
Yeah.
it's in shell lesson data. Do you mean that? Or
Yes,
some
exactly. That's
else?
the one. Yeah. All right. Quickly checking as well that people on the call have downloaded this particular folder directory that contains the data we will be using for this part of the session.
I will share the link again to where that is.
Right. Thank you, James.
I have a question at the chat side on listen. Hello,
Obi, could you say that again?
there's a question I asked on the list on listing on
Okay.
the chat side.
Let me check that out. Chat. It gave me so much time to find the chat. Sorry about that. Okay, yeah. So, oh, this is a good question. Yeah, I see you're already exploring. So, Obi is asking, what about the ls with the option -LRT? What does that mean? So, this is an option that allows you to not only list the content of your directory, but also to show you the last time that those files were opened. Maybe does that clear things up? Would you want to explore that on your computer and see what it outputs? So if everyone has this lesson data file, we're going to start doing some hands-on exercises. I'm going to navigate into this folder rather, that I've just downloaded this morning, and we can use that to work. Normally on my computer is a pretty easy way that I use to get to a particular folder that I want to open in my shell, but I will show you a longer process just so you understand the foundationals, and then I could show you the cheat code later. So the next command we will be talking about is the cd command. And like ls or pwd, it's easier to remember because it is change directory. So we want to change and move into a different directory. So we do cd desktop, for instance. and enter. You will notice that I'm actually going to clear and so that we can start on a fresh page because the screen was quite cluttered. And so that CD command and desktop, well, if I didn't want to type this command all over, I could just use that up arrow button to get the CD desktop. And it says no such file or directory desktop because I'm already in the desktop folder. And before we had just debs at Mac, nothing else, and then this percentage sign. But now the desktop shows because we've changed directories. We've moved into that desktop directory. But how do we know that we're in the desktop directory? What command could we use to confirm that we're in the desktop directory? Let's see. What command can we use to know that truly we're in the desktop directory and not somewhere else we didn't intend to go to? PWD. Nice. This is one way we could do PWD, print working directory, to show you where we are right now. So we've moved from that single user debs and we've moved into the desktop. That's very good. And another way we could use to validate that we were really in the desktop directory would actually be to do ls. And there we go again. You see all of the stuff that's in the desktop. You don't want to see what my desktop looks like. So I will, yeah, clear this. So now we're in the desktop directory and we want to try and get to this directory, shell novice main. So to get into shell novice main, I'm going to clear that up. We use that cd command again. So we say cd. And I just copy pasted that so that I wouldn't spell it the wrong way. And what do we notice now? The terminal is showing me that I'm indeed in the shell novice main, but I don't believe my computer. Why would I believe what my computer is saying before I do my PWD to be really sure? So now we're in users, debs, desktop, and within the desktop, there's a separator and shell novice main. And if we say ls, we see all the contents of that folder. You might see something that looks a bit different from what you have because you most likely only downloaded shell lesson data, whereas I downloaded the entire repository for no reason whatsoever. And I will pause and ask whether we've gotten this far. Who has successfully used the cd or change directory command to go into desktop and then into shell lesson data? Let's see. Who has gone from desktop into shell lesson data or wherever else you've put it? For you, since you downloaded this folder, it might be in your downloads folder, meaning you can't go from desktop. So you probably have to go into downloads and then go into this folder, depending on what your file structure looks like or your folder structure. green check marks if we've made it into the shell lesson data, or reactions in the chat, thumbs up. Or questions, asking us for help. We all okay to move on? Done. All right, good. I see one done. And last step, I'm going to actually change directory into the exercise data folder. So I'm going to actually show you the content of this shell lesson data folder. So it has two folders, exercise data and North Pacific Gary data. So I want to go into this one. So CD, exercise data. Okay, so Obi's file is zipped, so you just extract or unzip that file and you should be good to go. On some computers, when you tap on the file, it automatically allows you to unzip. Otherwise, you might have to right-click on the file and choose the option to unzip it. And just to validate that I'm really in my exercise data folder, I use that pwd. And yes, I've gone from desktop to shell novice main to shell lesson data and into the exercise data. What could possibly be the content of this exercise data? I wonder, how do I check that? ls and yeah. Right. What questions do we have about the commands ls, cd, pwd, or something else that we've talked about so far? Okay. A green check mark or thumbs up, just to be sure that it's okay for us to move on to the next section of the lesson. Green check marks, thumbs up, reactions. I'm good to move on. Okay, so Trevor's asking how we can go back to a previous directory. This is a very timely question because we were about to get into that part of the lesson, and in a few moments you would see exactly how to go back or forward or into a deeper level of a folder, etc. Great question. All right. Thank you, James. If anyone needs further help, please do not hesitate to ask. We have helpers and other instructors on the call. So great. So we've found our way into this exercise data folder. We've done ls to look at what's in the folder, but with the way it's listed here, I'm not sure what is a file and what is a folder. Yes, this has .txt, so I can guess that is a text file. But how about these ones? What are they? So we bring back that option of LSF, and this now shows us that, okay, these are folders. They are actually folders. And there's one file alongside those folders. And if, for instance, I try to change directory into a folder that doesn't exist in this exercise data, so I say, the first thing that comes to mind is gummy bears for whatever reason. So we try to change into a folder called gummy bears, and it says no such file or directory. When you get this error, you're either trying to go into a folder that doesn't exist, or you've misspelled one that does exist. So you've spelled it the wrong way, and you have to check your commands. So these errors are very helpful. So showing off what command would we use to ensure that we were in the exercise data folder. I want you to type that command in your own terminal and tell us what it outputs. This is a great way to ensure that we're all following. And if you do need help, you can speak up. So I want you to type that command that lets you know what folder you're in. That command, it prints the working directory. So type that and let us know what outputs it's giving you. Oh, Sylvester. Good. So it's in your downloads folder, and within downloads, it's share lesson data and then exercise data. Nice. And same for Trevor. This is good. Trevor has his in the root of the computer. Nice. I hope that everyone else has somehow typed this very lovely command and isn't having any errors being thrown back at them. So I like shortcuts when it comes to commands. I like shortcuts and I like them a lot. And there's a particular shortcut that allows you to move different levels of your directory or your folder, right? So we've seen where we are currently right now. This is where we are. If we were to type cd and ... something is going to happen, something really special. You're saying go to the, for us to visualize what happened, I'm going to do PWD and ask you to visually compare this and what we had before up here. What difference do you notice between where we were moments ago, right here, within that exercise data folder? And we did this one command and we printed the working directory to know where we are right now. And something changed. Something changed. What did change?
The directory in between is off. The
Obi?
directly, yeah, the directory between the desktop, in short, desktop and the share novice directory we are off. We are just on the main directory we are working on now. That's what
Thank
happened on your screen.
Thank you so much. That's a very good observation. Thank you. And Dave said in the chat that we went up one step in the directory tree. Yeah, remember how we described our file folder structure as a tree? We have the roots, we have the body, which is the trunk of the tree, then we have branches that then go into smaller branches. So we were within a folder, the exercise data folder, right? And we did this command and it brought us out of that exercise data. It took us out one step. So it brought us back here to shell lesson data. And what would make this particular action make sense to you is picture that graphical user interface we talked about earlier. If you wanted to go into a folder called pictures, you would click on that folder. And if you clicked on that folder and you had other folders that said, for instance, pictures of lions or pictures of dogs or pictures of fishes, and you felt like you wanted to look at fishes, then you would have to click into that fishes folder. And now you go into fishes and you have two more subfolders within fishes, one for large fishes and the other for small fishes. Well, I feel like looking at large fishes, and then I click into large, the folder called large. And within that folder, I can find pictures, right? So imagine if we're inside that folder called large. If we wanted to go a step back, if we changed our mind and said, yeah, no, I don't feel like looking at big fishes. Now I want to look at small fishes. If you wanted to go back, you would use the back arrow if you were using the normal graphical user interface. So similarly, this cd ... command lets you do that back arrow movement. It lets you go back. You've entered too deep into this pictures folder. You want to go back into the fishes folder. You could even change your mind entirely and go back outside, out of that fishes folder. So for instance, if you had pigs slash animals, and within the animals folder, you had lions and dogs and fishes, but you really wanted to look at fishes. And within the fishes folders, you had large and small fish, and you wanted to look at a large fish, right? So if you went into this large fish directory, you would use the back arrow. And when you do that back arrow movement, you're essentially saying, yeah, take me back to fishes. And you're here now. And if you want to say, yeah, I don't want to look at fishes, you go back with that back arrow. And if you change your mind entirely and you do this cd ... command, every time you do cd command, you're going a folder out of where you are currently, right? Which is why we were in the exercise data folder, within the shell lesson data folder, within the shell novice main folder, within the desktop folder. So every new folder is like a layer you're going into, you're clicking, you're entering deeper. But if you wanted to come out, you could use this cd ... command, right? So if we do cd ... remember we're here right now, right? We're here in user slash dev slash desktop slash shell novice main slash shell lesson data. If I pressed enter on this cd ... command, where would that take me? Where would I go next? Let's see. Where would that take me? If I'm within a folder, shell lesson data, and I used CD, which is essentially our back arrow, to come out of shell lesson data, where would I end up?
You end up at the base, the command line or at the base command line of Debbie at Mac.
So I would go back to, Obi, thank you so much for that attempt. I would go back to, yes, Debs. I would go here, like Obi said, I would go to Debs, but I would still be in that desktop folder. But now I would be in shell novice main, because for every single time you click, you go one step back. You don't jump all the way back to the very root. You don't go all the way here. You go back to the directory behind where you are, right? So you move from here, we're in here right now. So we use the CD command to go here. And I'm going to stop sharing my terminal for a very short moment to share something else. I hope this helps a bit more. Let's see, where are you, Zoom? Stop screen share and share this. Hopefully I have enough files within this pics directory to send the point home. So I've actually just opened this folder on my computer called pics. And within that file, I have screenshots. I'm going to try and find a folder that has other subfolders. Or for this lesson's sake, I could create a quick folder here. If this gets too complicated, tell me the moment it gets too complicated, please. Yeah, so I'm within pics, right? So this is basically me saying pics, and then I click on GitHub Workshop. That motion I use to click on GitHub Workshop is the same thing as me saying pics / GitHub_workshop, right? The name of this folder. Or if I said CD, change directory, GitHub Workshop. So that's this motion I just did. And if I did CD again, more pics, I'm moving into this folder called more pics by clicking on it. Right? But if I wanted to go back out of this folder, I would use the back arrow, but there's no back arrow on our terminal. I can't just conveniently use the back arrow or forward arrow to move. I have to use that command cd ... So every time I do cd ... this is what I'm doing basically. I'm doing this. I'm going back one step. Realize that when I went back one step, I didn't go all the way out to pics. I went just one step behind. So CD GitHub Workshop, it opens this folder. CD more pics, it opens this folder, right? But I have changed my mind. I don't want to look at this folder called more pics. So I can use this to just go back one step, or CD ... So CD ... CD ... It takes me back here. And I will resume screen share for the terminal so that you see how that applies to this command line. So we went into the desktop folder and then into another folder called shell novice main, and then we click into shell lesson data, and that's where we are. If we wanted to do that back arrow to leave the folder, the equivalent of that in Unix would be the cd ... command, right? Just this cd ... enter. And that takes us here. It moves us just one step back from here to the previous folder here, right? So if we do pwd, comparing this desktop / shell novice main, comparing it to this, which is actually a level inside, and even this, which has gone as far as the exercise data folder, right? So if I do this cd ... command one more time, considering that I'm here, where would that take me if it's taking me just one step behind? Let's see. Reactions in the chat, or you're feeling extra courageous, you could unmute and speak like Obi.
Please come again.
Yes, so I was asking, we are currently here in the shell novice main directory or folder, and we want to do that back arrow movement. We want to leave this folder and go a step outside of this folder using the cd ... command. So I'm asking, if we do enter right now, where would we find ourselves? In which folder would we be looking at?
In desktop.
Fantastic. Awesome. That made me very happy. Nice, nice, nice. Thank you, Sylvester. We will be in desktop because we're going one step back in the... So we're now in desktop, and to confirm, pwd, we're really in users desktop. So if we wanted to click into a folder, we would use that cd and the name of the folder we want to go into, right? Shell novice main is the name for me, right? And now we're in shell novice main. If we do pwd, we see that truly we've gone from desktop and we've entered into shell novice main. And if we do cd shell lesson data, now we're in shell lesson data, confirming it with pwd, desktop, shell novice main, shell lesson data. And we want to go into the exercise data folder. We do cd exercise data. And now we're right back where we started. So desktop, we move in, we click into shell novice main, and we click into shell lesson data, and then we click into exercise data. I'm going to clear my screen so that you don't have to be looking at all of these things competing for your attention. And what command would I use to clear? Yes. Thank you. Thank you, Trevor. And so I would use the clear command, and sometimes it's easier to just type the command and try to look for it in the history, as you can see in my case. All right, so we're in that shell lesson data folder. So there was a command that allowed us to look at what files, what content of a folder, which ones were actual folders. That command helped us to put a slash in front of folders. Do we still remember what that command was? Beautiful. ls with that F option. So ls F. Nice. So that shows us all everything that we have and which ones are folders, right? So I want to actually go a step back out of this to show you a particular function. So to go a step back, I would do cd ... and I've come out of the exercise data and now I'm in shell lesson data. pwd, I'm in shell lesson data. So sometimes there are folders that will not show up when we do the ls command, right? There are certain folders that are tagged hidden folders or hidden files. To be able to show everything, including the hidden files, we use another option called -a. So that A basically means show all, show everything, including the things that are hidden. And so we would do ls with that F option to show us which ones are folders, and an additional new option, A. So that shows us everything, including the hidden ones. Is there anyone who experienced something unexpected when they used the ls and F together with the A? Did you run into any problems? Okay. And if you're like me, you might want easier ways to get things done. Let's see. All right. Oh, I've actually just realized that I'm in a different time zone. And so in my head, the break should be in 1 hour, but the break was supposed to happen 8 minutes ago. And so I sincerely apologize for that. Thank you for stopping me in my tracks, James. That's very helpful. I'm going to rush through this particular episode, just get the meat out of this episode, and then we can go on break, stretch our legs. One more feature, and then we can go. Thank you, James. So I was about to mention how it seems a bit stressful to have to do cd / folder we want.
Sorry, Deborah. Thanks for
Yeah.
that, Trevor. Sylvester's has his hand up.
Okay. Sylvester, please go. Thank you, James.
So my question is that way we can just go back direct? Like maybe we are deep inside into, let's say, the shell lesson data, but we want to change our directory to maybe downloads again. Is there like a
Yeah.
single command prompt for that, or we just have to do the cd ...
Yeah, that's a great question. And as before, you've foreshadowed what we're about to do. So the answer to your question is pretty much this section we want to do now. There's a much easier way to go from folder to folder without having to do cd ... or cd the name of the folder. We can do it all in one single command rather than having to do cd / whatever the name of the folder we want, right? So if we wanted to go into, I'm going to navigate back to desktop. just so we have enough room to move around, I've come back to the desktop. And if we want to go directly into that exercise data folder, there's a much easier way to do that. So I will list, if I list my desktop files, that would be too much. I wanted you to be able to see. Okay. So we can actually just go straight into the shell lesson data folder and into the exercise data in one command. If we do cd, and for me, the folder is called shell novice. I cannot type today. Main. And we put that separator, right? And we say shell lesson data, right? And then we go / exercise data. And when we do enter, hopefully if we've typed everything correctly, it should immediately take us into that exercise data folder. And if we print the working directory, we see that we've gone exactly where we need to go. So that's an answer to Sylvester's question and also part of this section of the lesson to show you how you can move from folder to folder using the entire path. So this is where the subject of path comes in. If you know where that folder is, the path to it, so it's like when you're going to a location, a specific location, if you know the path, then it's easier to get there. So you put cd and then exactly where that folder is, and you go there straight up without needing to do it one by one. Cd shell novice main, and then cd shell lesson data, then cd exercise data, right? And we will just talk very quickly on absolute and relative paths. Then we can go on a break. So on the subject of absolute versus relative paths. Remember, the path is this entire thing here, showing you the specific location of the file. So dev/desktop/ shell novice, that's the path. So, but we have absolute paths and we have relative paths. So I'm going to clear this up. So I'm actually going to ask us to pause here because it might defeat the entire purpose of this lesson if we have to rush through to go on break. So we will pump the brakes at absolute and relative paths so that we take as much time as we need to really imbibe and understand it and not just merely run through it. And so, yeah. James, I think it should still be fine for us to take that 30 minutes break and come back 15 minutes later than we anticipated. How does that sound?
Yeah, what do people want? We could come back in 15 minutes if people think that will be enough time, or if people want half an hour, we can also do that. Does anyone have a feeling about that?
Okay. James, the mantle has fallen on your shoulders. I think you do have to decide.
Or maybe we come back in 15 minutes. I'm gonna go and have some
Okay.
food and get a drink, and then I'll be ready. I guess also if that's okay for you, Deborah, who's been doing the most of the work this morning.
Yes, that's fine. Yes.
Cool. All right. We'll see you all in 15 minutes.
See you. All right. I hope people had some time to stretch their legs, or if you're like me, grab quick breakfast or grab a drink. And yeah, we'll just pick up exactly where we left things. So before I'm going to quickly check that people are actually back. I will ask you to please give a thumbs up. I see Trevor is back. Thank you. I'm going to quickly check whether others are here. Thank you. I see another thumbs up. Okay. Okay, so we were about to go into the subject of absolute versus relative paths. And that was just before the break. But I'm going to check people's knowledge of a few commands and then we head straight on. I just want you to tell me what these mean in the chat and then we run. Just these 3 commands. What would they do? Feel free to unmute and speak if that's easier for you. So you remember, this is to print the current working directory where we are. This is to go one step out, and this is to list. I will introduce a new symbol, which we call the tide symbol, and it's somewhere, it should be somewhere close to your escape key. There's an escape button at the very edge of your keyboard, the key that looks like it's about to escape. And under it, you would find the tide. So the tide takes you back to, if you click enter on tide, yeah, permission denied. Shell doesn't have rights to do something this elaborate with my computer. But this should actually take you all the way back to that home directory, back to the root. And this is an easy way to navigate. If you remember, before we went on break, we were comparing the option of CD, and then you put every single folder name after CD. But there's a much better way to do it, as we've seen. You can type the entire path. And it's in the same vein that we can just use the tide symbol and go straight up from where we are currently within exercise. You can just move into a different folder using tide and then dash. So CD, of course, we don't forget that change directory, and then tide. Tide is saying, take me back all the way to the roots, give me a fresh start, and then you can add the path. You can just add the path of where you're trying to go next. Add it all the way, and at the end, you do enter. Depending on where you've downloaded your lesson. So right now I'm within this exercise data folder. I'm going to do ls to see what's in there. I want to go into this creatures directory. So if I do cd creatures, that should take me into the creatures folder. That in itself would be a relative path because I'm trying to go to a folder within my current location. So it's related, so to speak, it's related to the folder where I am. If I just do cd, I go into creatures, right? No, sorry. cd creatures. So that takes me into the creatures directory. And hopefully now you have a better grasp of how you can move from one directory to another. And if I wanted to go away from this directory, from creatures, I could indeed. I saw Sylvester ask this question. That was a really good question. If we can type one single command to go into a deeper level of a folder, can we do the same to go all the way outside a folder? And truly the answer is yes, because with that cd ... command, you can do cd ... use a separator, go ... use another separator and go ... So you're going all the way back, all the way out of the folder. And hopefully this does make sense. It makes sense that with this first keystroke, we've done that single back arrow to come out of the creatures folder. And with this next one, we've done another back arrow to come out of exercise data. And with another ... we've gone all the way to shell. If it sounds complicated, you might want to look at this path here and compare it. So every time you do ... you're moving backwards. So instead of having to manually do cd ... 100 times, you can just do cd ... slash ... So that helps you get things done faster. And it's always good to validate to know exactly where you are. So that's the central idea behind okay, so there's a question in the chat asking, why don't we do cd creatures? So let's attempt to do cd / creatures. And what we have is an error because there's no, you can't lump together the command and the name of the directory you're trying to get into. You will run into problems because remember that this is a separator and this is a command. A separator shouldn't be used to, the separator shouldn't come between commands. It's a separator that exists to show you the path. So it's used between folders, not to separate the path from the command, if that makes sense. So the command has to stand on its own. You put anything else that needs to go dash and then anything else dash, right? And hope that answers the question that was raised. Yeah. All right. So we've spent some time talking about our commands, but we want to get familiar with the terms that we might use for these commands so that if someone says, argument, if we hear the word argument or we hear option, it doesn't get complicated for us. We still know exactly what they're talking about. And so I will just write a dummy command here. Let's use one of our favorite ones. This right here, the percentage sign, on your computer, that percentage sign should show up as, it could show up as a $sign if you're not using the same operating system as me. So this is called the prompt. If it's a $sign for you, you don't have to write another $sign when you write your command. And ls would be the command, right? And then the option would be -f, right? -f. And then whatever comes after that option, if it's not another option, remember how we did dash, we did -f and we did -a. So if it's not another option coming after F, whatever will come after F would be your argument. So basically giving extra context, giving your command the exact behavior you want it to execute, right? And you might hear some people call options, which is this, options or arguments. You might hear them use other words for it, like parameters. They're just referring to the same thing. It's all vocabulary. So we did mention that there's so many things you can do with the power of the Unix shell. One of those things is that you can count, you can show size. So some of the options allows you to show size of files or of folders, and we're going to look at that. I will go into the desktop folder, shell lesson data, and then we will do a special command that will show us the size of the files or the folders. So right now, pwd, I'm in, okay, I'm actually going to clear this screen. pwd shows us that we're just in the shell novice main, and I want to go into the shell lesson data just to buttress the points that we made earlier about absolute and relative paths. So I want to go into shell lesson data. It says no such files. I probably should have done my ls to know exactly what folder I'm trying to get into. So I'm trying to come here, shell lesson data. If at any point I become too fast, please let me know if something is hard to understand, and I will definitely come back to explain it better. All right, so I wanted to show you this function, this command that you can use to count or check the sizes of things. And remember, we have this folder. If you do this command, it's going to show you those folders, but this time it won't be just folders, something is different. So we have numbers in front, 0, 0, 8, 0. So these numbers are showing us the size of the files, right? What's within these files. And to validate that this is true, let's try and go into alkanes and do ls to see what's within alkanes. Let's try that. Exercise data. Okay. So we have a couple of files within the alkanes directory. I will pause and ask what questions we have so far. Right. So in this particular section, we've touched on what the file system looks like, how folders are organized within folders, and within folders you can find other files. And we've talked about how information can be stored in files. We've also used the command pwd. If we remember, that prints the current working directory. We've learned how to use the ls to list. We've also used cd, which is to change the working directory. We've learned how to go all the way into a folder without needing to go cd each time for a different folder to list them all by using the paths. We've also established that the absolute path, it specifies a location starting from your current location. So you can go from downloads folder. While in your downloads folder, you can go all the way to a file that's in your desktop, right? Because you know exactly where it is in a different folder. Whereas a relative path, you need to specify it using your current location. And next, we're going to learn more about working with files and directories. There's a question from Bertimelo. Do you want to unmute and ask? I'm not sure I understand.
Hi, thank you. I was asking regarding on the interface or what I can see from your screen. You have open bracket base and close bracket. I don't have it on my PC, so I would like to ask what is its purpose.
Okay. So this is thank you very much for asking and assuming what it means. This is I'm using a Mac, and the command line interface would look different from yours. So
I'm not sure
sorry.
if I got you. Sorry.
So if this is, it's like describing what environment I'm using. So if I were to, I'm skeptical about using this example because that would bring a comment about Python. But if I were to be using like a virtual environment, a different kind of environment, then it would specify it in there in the bracket. But this is just like a default. Yeah, I think that's the best way to explain it. This is a default.
Okay. Does it mean for me that it's because you are using a Mac? Is it the case?
Yes.
Oh, okay.
Yeah. So
Thank you very much. I got it.
yeah, you're welcome. Do you have a different one displayed for you? What OS are you on?
I'm using Windows. Yes,
Okay.
I have Ubuntu. So it doesn't have, I don't see base. So I was asking if it's mainly for Mac or I chose a different setting.
Okay.
Mm.
Okay. All right. Awesome. And if there aren't any other questions, we could start chatting a bit more about working with files and working with directories. And you get, okay, Sylvester has a hand up. Please go ahead.
So I'm trying to track what you've done past the other command, the ls-s. Then it gives me these words with figures or numbers before the actual words. Then you've gone ahead, then keyed the cd exercise data stroke / alkanes. I've tried the same thing on my end, but it says no such file or directory.
Could you maybe
Hello. Hello.
Hello, Sylvester. I can hear you. I can't hear Deborah though. Deborah, are you still there? Maybe she has connection. Sylvester, you said that when you tried to do CD exercise data alkanes, it said no such file or directory.
Yes.
It's possible that so as we were just saying, this path is a relative path, and it might be that you're not in the parent folder of exercise data. So the two things you can do to check is first, you can do ls, and this will tell you everything that's in your current working directory. And the other thing you could do is pwd to print your working directory, and that will confirm that you're in the place that you think.
Okay, I'm currently in the the exercise data.
Data.
Yeah.
And if you do ls, what does that produce?
It produces alkanes, animal counts, creatures, writing numbers.
Okay, so you're already in the folder that contains
Yeah, well,
alkanes,
I
and
was just trying to follow up what she did, but mine on my end it says no directory for such file.
so if you wanted to move now to the alkanes folder, then you would just do cd alkanes. You
Okay,
don't need
okay.
to have so the first part of that path was the folder you're already in.
Yeah.
And
Okay.
so the computer can't see that again.
Okay, thank you.
That should work.
Yeah.
I guess we have connection problems. We'll give Deborah a
Yeah,
couple. Oh, you're here?
I've
You're here?
yeah,
Hello again.
hello. I have arrived. I'm sorry about that. My
No worries.
router died. Yeah. Okay. And hopefully in the capable hands of James, you got an answer to your question about the LSS.
Yeah, yes. Thank you.
Brilliant. Thank you. And thank you, James. Yeah, so we will talk a bit more about navigating files and directories in the next 27 minutes. And primarily, we want to know how we can move around files, and we want to really see the content of each of the files. So before we can just do ls and see what's in the folder, but now we want to read the content of files. Normally, have I died and disappeared again? No, I'm still here. Awesome. So we want to learn how to create, copy, and delete files and directories. So I'm going to ask you to please, I'm not sharing my screen, am I? Oh, no. 1 second while I share my screen, please. There we go. Checking that everyone can see the screen. All right.
Yep, we can see.
Right. Okay. So now we know about the different files and directories, but how do we create a file if we didn't have this example folder structure? How would we create files by ourselves? So I want to go back one step into the lesson data. So I'm right there in the lesson data, and just to be sure, PWD, yes. And we want, so I would ask you to please follow along. This is really important. We want to attempt to create a new directory. It's ls. A new directory called writing. So my shell lesson directory doesn't have any folder called writing. So we want to make this directory. So the command, there's an airplane passing. I don't know whether you can hear that, but please ignore it if you can hear it. I suppose you cannot ignore it after I told you about it. So the command to make a new folder would be mkdir. And intuitively, you might already have a sense of what this means, kind of like how ls meant list and pwd was print working directory. So mkdir be to make a directory. I want to confirm that this writing folder really does not exist. Okay. I'm going to go into, yeah, so I want to point out the use of a wildcard. It might save us some time. If you know that this exercise data folder is the only one in that directory, it's the only one, like we can see here from our LSI, it's the only one. Rather than having to type cd exercise data, we could just do exercise and finish it up with the wildcard, which is your asterisk. And it's saying, open the folder that begins with EXER. And it does open the exercise data. So that's a quicker way to get from place to place. And I want to do ls here. And indeed, we have a writing folder. I want us to go into that writing folder and see what's in there. ls. We have two files, one called littlewomen.txt, it's a text file, and another called haiku.txt. So if we do, I apologize, I do have to clear my screen so that everything comes to the top. But hopefully that did give you enough time to look at how we got into the writing folder. If you haven't gotten there yet, please let us know. And within that writing folder, you have littlewomen.txt and haiku.txt. But we want to create a new folder right there within writing. Remember that this marine biologist is trying to write a paper. So it will say, make a directory and call this directory thesis. And let's see whether we did create that directory. And yes, it's right there. Confirm it's a directory. Use that lsf command. And we see that thesis is there. If you've been able to create this thesis directory, give us a thumbs up or let us know in the chat. Yes, I see you. A couple of thumbs up. Very nice. Okay. So we've created that thesis directory. But it's empty. There's nothing within that thesis directory. But if we want to create more than one file within this place at the same time, there's an option that lets us do that. So we have this thesis directory here, right? So we come back here. Gonna stretch out my screen a bit. Yeah. And we go make dir. Okay. So this is us attempting to create more than one subdirectory or multiple subdirectories at the same time. This might look a bit more complex than what we've been doing up until this point, but just stick with us. And we say projects. So we want to create project, and on that project create data. And with a space in between, we can do that same thing and say project results. Before I click enter on this one, I want you to take a moment to just really look at this. I will slim this down and zoom in a bit. Yeah, okay. So looking at this, it gives you a sense of what the expected end results might be. So we click enter and we attempt to do ls again.
We lost Deborah again. Hello. Am I lost? No, I'm still here. Sorry, bear with us. I'm sure she'll be back in a sec. Obby's just asked a question in the chat. Why is the -p directory not found after you list it? This is a really good question. So what we were doing there is using the -p to make two folders, two directories at the same time. So we were using first the project, first a new folder called project, and within project you have two new folders, one called data and one called results. But if you just list at the folder that contains project, it will show you that project now exists. And if you want to see what exists within project, you would have to list project. I hope that makes sense, but we will look at that as soon as Deborah returns. Anyway, we'll demonstrate that. We'll just give her a couple of minutes, otherwise I'll show you the next steps which answer that.
Hello.
Hello, Deborah.
Sorry. Let's try this and hope that the internet gods are in our favor at this point. All right. Yeah, I'm not sure exactly where I dropped off, but we were experimenting with creating directories, but doing that in a more streamlined way, in a single stroke. So we created this new folder, projects, and within that we made data. And within that same project directory, we made results. That's results folder. And we wanted to visually look at these two folders that we've created. So if we do that command, here, go, F. So at the exercise data folder, we've created this new folder that didn't exist before. We've created projects. And within projects, if we go into project, we should be able to see that data folder and that results folder, which we created in one single stroke. So let's go into projects and have and I think it's great that this error happened in real time. So you see how easy it is to make mistakes. So if you look here, when we made that new directory, we did ... meaning go to the folder outside where we were, create a new folder, projects, and put a data folder in that. But for this one, we missed a single slash right here. This slash should have been right here as well. And because of that one tiny thing, we only have a folder for data, but no folder for results. Hopefully that makes sense. And now we do need to create the results folder. How would I? So if you did the whole command the right way, then you should have two folders here. But we will just create a folder called results. And if we do our ls, we should have two folders. So this is pretty much how you could make a directory in one single stroke, or do that multiple times if you make a mistake the first time. And let's quickly talk about naming conventions for folders. If you make your folder name too complicated, when you need to navigate into that folder, it makes it much, much harder for you. So imagine having to type a folder called screenshots from the year 2009. Imagine how hard it would be to type CD screenshots from the year. Like, you could make so many mistakes. But if you used simple, straightforward names for folders, then it's easier to navigate. And by convention, we like to separate folder names. So if you have two names like exercise and data, we prefer not to write it this way because it's harder to read. So we write this way, or we write this way. So it's so much more logical to read folders when you name them this way, as opposed to naming folders with spaces in between. We don't want to name folders with spaces. If we want to make a dir called maybe Pacific Rim, we don't want to have Pacific Rim with a space like this. We instead want to have it this way or this. And by convention as well, it's not recommended that you start the name of a folder with a dash. So dash results. Intuitively, you might see how this looks a bit like our flags that we use or our options. So we don't want to confuse this innocent software that's helping us. So that's just a quick word about the naming conventions. Also, try not to put too many complicated special characters in your folders, like asterisks, folder, hashtags. It makes it so much harder for you to do the right thing. So we will go into that thesis folder and attempt to create a file called drafts. So our scientist wants to start creating a draft of a folder. So I will go back here. Yes, be sure that we're in the right place. And I want us to come into writing. So cd into writing. And be sure that you're in writing. Yes, we're in writing. I will clear so it all comes up. And within that writing, so actually I'm gonna go back. So we want to do our writing in thesis itself and not within the writing folder. Anyway, yeah, thesis is within, there we are. So we go into thesis and we make a new file called the draft txt file, but we're not going to say make dir draft.txt. Why might we not want to use that command make dir for making a text file? What thoughts do we have? Why does it seem wrong to say make dir and then draft.txt? Exactly. Awesome. Yeah, so make dir, make directory is for directories, which are folders. So a different command makes the drafts file. So we have nano draft.txt. And behold, this looks indeed a bit strange, but over time you get used to something like this. So this opens your txt file. So right here, if you look here, oh no, if you look here, you see thesis and then nano draft.txt. So we've made a new file called drafts.txt and we've opened it in like a text editor so we can write within it, right? And so nano is one of the alternatives that you can use as a text editor. Most often people would rather use other interfaces like if you've heard of VS Code or Vim or Emacs or any other of these text editors, but Nano is quite lightweight and relatively easier. But once you get comfortable, you choose your weapon. A lot of people like Notepad, just a regular Notepad on Windows. But yeah, this is what Nano looks like. And it has certain commands. Let's attempt to write a few things. And I'm a bit out of ideas, so I say, what shall we write today? So, and now you can easily add content to that draft.txt file. Remember, we've done all of this within the Unix shell. We didn't have to click a single button, all using commands. We navigated to folders, we created a new file, etc. And so if we're happy with the text that we've written, we can use, so on the Windows, that would be Control, right? Control and 0 to save. But if you were on a different OS, you could use your Command and 0, right? So give that a try and see whether it works for you.
Hello.
Yes.
So sorry, I was trying to follow up and I was kind of lost. Then when I came back to view your screen, I didn't know how you got here where you opened the thesis nano draft text. So I'm still on
Okay.
the thesis, on the CD thesis.
Okay. Thank
Okay,
you
thank
for
you.
letting us know. If you're in a similar situation as Sylvester, what we did was to go into that thesis folder and we wrote the command nano draft.txt. Nano, like NANO here, and draft.txt because we're trying to create a draft file for that scientist, for that marine biologist, right?
It's
And we just wrote some text into the draft file. So that's how we
okay.
got there.
Is the nano draft one word or like nano space draft?
Yes, so it's nano space draft dot the txt. So draft would be the name of the file and the extension is .txt because we want to create a text file. So Nano is the text editor that we've used to open that new file that we created.
Okay, thank you. It's worked.
Fantastic. That's awesome. Right. So we've written some text into the new file called draft.txt. And so the text is just plain characters. We can put images in here or tables or other things. So to save that, it will be Control and the zero button. Hold Control and 0. Okay, and so I've saved mine. And to quit the editor, like to leave this entire interface, right here at the bottom, you will actually see some of these commands that tell you what to do. So this Control X, which you would use to cut text typically, lets you escape this text folder, or this text file rather. So Control X, and then we can go away.
So sorry to interrupt. But you said saved, and I tried saving, but it's okay. I don't know how to save it because I've gone to the thesis. I've traced my way back to the thesis, and it won't save.
Sorry?
Okay, I pressed command O to save.
Yeah.
Yeah, then it opened the finder. So I was trying to select some folder to save it in, but I don't know if I should create a new folder or something like that because it's just I've opened the thesis, I've traced my way to the thesis, and it's still
Yes.
opening.
So when you did Command X, if it asked you whether you wanted to save it with a particular name, did it?
Oh, it's Command X. I used Command O.
Yeah.
Okay, let me try Command. I just press it once and nothing happens. Like that is what I've just done right now.
So when you press the Command X, nothing happened.
Yeah, nothing happens.
Yeah, so Command O gives you an option to save the file, and then Command X lets you exit this editor.
No, it's I think let me try because I can see some, how do I call them? They look like keys. I think control X. Yeah, control X.
Hello.
It's Control X.
Okay.
Yes.
My own, can I say
Can I?
something? Can I
Yes,
ask a
please.
question?
Yes, go ahead.
My own says I did Controls O. It gave me file name to write. Then he brought out
Yes.
draft.txt.
Yes.
So I don't know what X again
Yeah.
to do.
If you press enter, then it accepts the draft.txt as the file name.
Okay.
Awesome.
Okay.
Thank you for following, Obi. Yes. Wait, Melo, were you going to say something?
It has saved
Yes, I
it.
was going to say something before you answered. I wanted to add or comment that what I did is I did Control O and then enter and then Control X. That's how it was saved.
Okay. Okay. Yes. Control O, Control X. All right. All right. So does it now work for everyone? Does it work now? Green check marks if we've been able to do it up to this point. Or thumbs up. Yeah. Yes, I see Sylvester. Okay, yeah, I see a thumbs up from Travel. Umberto Mello. Obi, I think it worked for you already. Nice. And the news flash is Command X won't let me leave. Hey. So I've saved the file now into my desktop.
Is it a window thing?
Yeah.
Because I had this problem before where maybe do you need to select the nano window again and then do Control X?
Yeah. I think it's a glorious Mac problem, but now it does work. It doesn't automatically give me the option of saving into the
Oh,
lesson file, but
okay. I think
We
if you're using Mac, I tried Control X. It should work. Not Command X. It's Control
yeah.
X.
Thank you.
How do you check what you've written? You use editor. I don't know how to open the file to know what you have written.
Yeah, so that's the next part we're going into, to know exactly how to use the files that we've written to read those files, add text to the files, etc. Things like this. Okay.
Hello.
Hello.
So
So
seeing your screen. That is what I did the first time. That's why I'm telling you. You need to go back, then use Control X, not Command X. Control X. If you're using a Mac.
yeah, so I'm actually stuck at trying to save the
Yeah.
file.
Yeah. Just use Control X,
Okay.
not Command X. It's Control X.
Yeah, command, option. None of it actually works for me on my
Okay,
end.
it worked on my side. I used the Control X, not the Command X. Oh, yes,
It's
it's giving exit.
yeah.
Yeah. Okay. Sorry. Why do worked? Sorry.
Yeah, it's yelling at me for doing exactly what I should be doing. That's not fair. And we've got 3 minutes before our break, but
one thing online says maybe Control Shift and X on Mac, like more recent Mac.
yeah, Control Shift and X doesn't work either.
The text edit, well, they're very useful, very important, but they're not always the easiest to navigate. So this is a real example of the real conditions working with text editors, isn't it?
Yeah. And it's refusing to obey me, its master. Oh well. I'm going to forcefully close my terminal and hope that in closing the terminal, that actually does help with escaping this black hole. So let's see.
Seems like quite a common problem, just Googling what the solution might be. There's
Yeah.
lots of requests online.
I suppose it makes sense that it would be a common problem, because then I know it's not just about this particular terminal. I'm skeptical about trying that again, because then we might not know how to escape. This is my favorite method for navigating to a folder, is while you're at CD, you just drag the folder. So CD, and then drag the folder you want to open into the terminal interface, like you were trying to upload it.
It's 11 hours.
So how are we feeling? We're at the hour where we should be taking our lunch break. So
I
and take
think we have one more hour here. Is that right? I've got
we
at least lunch break 1 till 2 local time, right? So I think that's 1 more hour.
yeah, so lunch break for me is at 12. You're 12. Let me give this to you in the chat.
Ah, yes. This one says lunch at 12 local time. Right. Cool.
Okay. And do we go eat now?
Start the computer, the your laptop to help when maybe there's a jam somewhere. When the computer is restarted, it can sort it out.
Oh, that's a good point. Good point. Thank you, Obi. Right, we could break for an hour and then come back at 1 p.m. should be in your local time, but then 12 for me.
Cool.
Nice. And hopefully the text editor will be more cooperative when we come back. All right. See you all in an hour.
Right. Thank you, Deborah. See you, everyone. See you in an hour. Well, I'll just say that I'm gonna probably stay here for a bit working, and I'll keep this open. So if anyone wants to ask questions or if anyone's got any problems, we can follow up quickly now, like at some point, anytime over the next day. Hello, TG. I'm here now. Sorry, I missed your comment before. What? Hello?
James, did you say something?
Yeah, I saw in the chat someone wrote anyone.
Oh. All right. Vamos. We are break. Vamos.
I'll see.
Can't you know like patch?
She's back at the old hood.
Oh, different house. Different house.
Okay, different house.
Era house women.
I get
All
alright.
right. Yeah.
Shop. What's wrong, guys? No.
All right, friends. Hoping that we're back and we had a long hour to eat and maybe take a quick nap. Hopefully no one napped and forgot about this workshop. Could we see thumbs up or green check marks or reactions in the chat so I know everyone is back? Beautiful. I see people are starting to come back. Nice. Right. I'll resume my screen share. Right. And let this a quick recap. So we're still on the Unix shell lesson. And so far we've learned about this wonderful software, this program that allows us to find files and folders on our computers and to execute commands that would be too repetitive or too strenuous for us to do and do it more accurately. We've looked at the ls command, which we use to list the content of a directory. We've looked at the pwd command, which we use to print the present working directory. And we've also seen cd, which we use to change directory, and cd ... which we use to go back. And just before the break, we were talking about how we could create files and look at those files directly in a text editor called Nano. So if you remember our draft file, we had created a draft file by doing nano draft.txt. So draft is the name of the file, and we opened it in that text editor called Nano. Now, there's so many other ways to do this same thing. So for every command, you could probably find multiple ways of achieving the same goal using other means. And before I go on, I'm actually just going to confirm that we have that draft.txt file in this thesis folder. And we do that by listing. And of course, the draft file is there. And if we wanted to create this same file, but using a different method, we could use another command. And this command is called touch. So touch, what shall we call this file? Let's call it new file.txt. So this would still give you the same result as nano new file.txt, but touch only creates the file. You do have to open the file using a different command, which is why it feels like nano might be a more straightforward way, but that just means you do have to open it in the text editor. Nano, what if I don't want to open the file? I just want to create that new file. So you have this convenient command, touch new file.txt. And to execute this command, we press enter or return. And so let's see whether we've created this file. Yes, and it's right there, new file.txt. And so we know how to create a new file, but what if we want to delete a file? Normally we would, while using that graphic user interface, we would drag that into the recycle bin or right click and delete or use Ctrl D or Command D, but you can still do that same thing right here in your terminal. So the command for that would be rm. Intuitively, you might know that this is remove. So ls for listing, pwd print working directory, mkdir make the directory, and rm remove. So remove my file.txt and run that command. So I've tried to remove a non-existent file. I've tried to remove my file, but what I have here is new file. So it's yelling at me, you don't have a file called my file. So remove new file.txt. And if we run ls, the new file is gone. So for every single file type you have on your computer, the name, the real name of the file is right here. This part, the part before the dot. And then from the dot down to the end is what we would refer to as the extension. And the extension gives you a sense of what type of file that might be. So whether it's a song.mp3 file. So if you see a file titled .mp3, probably already know that this would be an audio file. And if it's .mov, might be like a video, a movie, it could be in MP4, it could be in PNG or JPEG to show you that it's a specific kind of image or it's a PDF. And maybe at this point you become so conscious of the different extensions on the files that you have on your computer. Let's just to quickly mention that. So have we successfully created this file called newfile.txt, and did we run into any problems trying to delete that file to remove with that rm command?
Hello.
Hello.
So I've done exactly what I've done, but there's a slight difference.
Okay.
Mine is giving me draft.txt.save.
Yeah, so I had the exact situation on my computer earlier when I created that nano file. So we ran into a challenge trying to close that file. Remember with the Command X or with the Control X. And somehow we added .save to the name of that file. So it gave us an error file. What I did was to rename the file. So it looked like this, draft.txt.save. So what I did was to rename the file and take out this .save part. So the actual draft.txt file, if you go into it, has the text that we had written and it works just right.
So do I do that from the Finder or from the terminal?
You could do that from the terminal, but it might be easier for you if you just go to Finder, locate the file, and rename. So what I did was Command Spacebar to search for that file quickly. Or if you could go to exactly where the folder is, you can do that as well. But I used the shortcut to get to that exact file and renamed. Does that sound good, Sylvester?
Oh yeah.
Alrighty. Next, we will look at moving files or folders from one location to the next. And with that, we'll introduce a new command. And this command would help you take a file like draft.txt, for instance, and move it into a different location. So for now, within this thesis folder, we have one single file, draft.txt. We're going to attempt to move that from the thesis folder and move it somewhere else. But before that, let's attempt renaming a file. I think it's quite a serendipity that anytime someone asks a question, the question usually leads us into the next part of the lesson. Very nice. Okay. So making sure that you're in that writing directory is, I'm gonna go back and to ls. We want you to be in that writing directory here. This is where we want you to be. And that writing directory is an exercise data. So once you find your way in there, we will rename a file using this move command. And I will explain what this means. Let's see the into writing. So the new command to either rename or to move. So to move a file and to rename a file, we use this same command mv, which is move. But when you use mv to rename a file, you're basically saying, take the information within this file and move it into a file called the new name of the file .txt. You're not really physically moving locations, but you're changing the name using that same move command. And this will make sense when we practicalize it a bit. So now within this thesis folder, remember we have that draft. So we will say move thesis. This is us going into thesis and draft.txt, right? Space, this is really important, space, thesis, / the new name of that file. So this command from here, you're basically saying within the thesis folder, there's a file called draft.txt, and I want to rename that as quote.txt. Keep it exactly where it is within that thesis folder, but change the name. And if we run this command, it doesn't look like anything has happened, but let's go into thesis, right? And if you look at this, you will see that the file that used to be called draft.txt has changed to quotes.txt. Do we have questions about this particular command, this whole operation that we've executed now? Does it make sense how we've renamed draft.txt to quotes.txt? All right. So if you take note of this name quotes.txt, and we attempt to do the same thing that we did before, but in reverse. So we changed the name from draft to quotes. So we want to change quotes to drafts and see whether that works. Thesis, quotes, space. Very important to put that space in there. and we change it back to drafts.txt. And we do ls for the folder thesis. And now quotes has gone from quotes right here to drafts. Can I pause here and ask whether anyone has successfully renamed this file the once or twice? You do have to be really careful while doing this command though, so that you don't overwrite files or delete files or lose any of the data that you've stored in your files. Has anyone successfully renamed the file? Remember, if you do need help with anything, if you get stuck, you can just let us know and we'll help you come back. Okay. So we're going to attempt to move this file called draft.txt. We're not renaming this time. We're going to actually try and move it to a different folder. And it would say move thesis dot draft dot txt. And here, after the draft.txt, you specify the location where you want to move this into. If you put a single dot, you're saying just take it one folder back. That's all you're saying. Just take it one step outside the folder where it's found currently. And if you do enter, how do we know that this file draft.txt is no longer in thesis? We're going to ls thesis and see. So there's nothing in there. If we had a file in there, it would show us right here. But now there's no file because we've moved it up. But where did it go? It went a step behind thesis. So we're just going to ls and see whether indeed we've moved it a step outside thesis. And indeed, we're in the folder that contains thesis, and our file has actually jumped out of this thesis folder. And yeah, let me do this instead, so you know which ones are files and which ones are folders. So it's jumped out of this thesis folder to just be here as part of the writing directory. Well, that's super helpful. So we'll try to read the content of a file. But so far, we've done two really important things: renaming a file and moving a file. And I'm just going to ask you to please leave an indication of some sort in the chat to be sure that you've tried that out and it worked.
Hello.
Yes.
So I've tried the move thesis stroke /draft.txt, but
Mm-hmm.
the response is it's giving usage. Then there's a source target, source, then directory. I don't know if it's the same for you because it's different from what I'm seeing on your end.
Yeah. Could you paste the output in the chat so we can look at that?
Okay, let me try to copy it.
Nice, it worked. So do you know what working directory you were in while trying to move?
While trying to move.
Yes, while trying to move the file or rename the file, did you take note of what directory you were within when you did that?
Yeah, I mean writing. I mean the writing.
Okay. And then you used this command to try and rename the file?
Yes, I've renamed it. It was successful.
Nice. And then, so the problem is trying to move
So the
that
next line.
renamed
Yeah.
file?
Yeah, the next line. The next line.
Let's
Or
go.
do I need to
Yeah.
put that? Do I need to put that space then the full stop? Because that
Yes,
is
you do.
that is-
Yeah, you
Oh.
do have to do the command mv, that's move, then
Okay.
the file, which is your target, thesis/drafts.txt. But if you've renamed the file, remember to use the actual name of the new file. So if it's quotes right now, it will be quotes for you as well. So quotes and then space and the dot to give a location where you want to move it to.
Okay. Yeah, I think it's now okay.
Awesome. It's good to know. All right. And we're going to try to copy files and to copy folders, right? So there's a command for copying files and copying folders. It's pretty similar to the move command, but instead it copies rather than explicitly moves. I will clear this terminal and have a fresh start. So we have a new command called copy. We want to copy a file quotes.txt. I'm going to ls-thesis and be sure that ls-thesis is empty. Let's cd into thesis and make, but that would be to create a file. So let's touch a file. What I'm doing now is to try and create a file so that we can copy that file. Alternatively, we could just move the file that we had moved out back into thesis. But now we want to copy quotes.txt and copy it into a new file called quotations.txt, right? So the way we would do that is first we ls to be sure that we have this quotes file, yes. And then we copy quotes.txt and give a target for this thesis / the new name of the place you want to copy your file into a txt. You do have to be careful when you type because any error in your spelling could really impact on how it runs. So copy quotes.txt into thesis quotations.txt. It's screaming at me. Do we know why? So the command usually explains what the problem is. It's saying there's no such file. What are you trying to copy? This file doesn't even exist, right? And so I would come here and I would touch quotations. txt. Now that I have a quotations file, if I run that same command, yeah, it still screams at me. I'm going to quickly check my spellings and see.
I think you're supposed to touch quotes.txt.
Dave, would you come again?
I'm saying I'm saying it seems I expected that you do touch.txt, not quotations, because we'll be copying as quotes.txt to quotations.txt.
So you mean we shouldn't be creating a new file called quotations.txt? Is that
My thoughts, because the destination file will be quotations.txt, right? And the origin will be quotes.txt. So my expectation was that we'll do a touch quotes.txt and then run the cp command.
Yeah, we do have a quotes.txt file. We do have a quotes.txt
Oh,
file.
okay. I
Yeah.
see. Okay. Okay.
My
All right.
concern, I'm really wondering why it would throw this error when we're trying to copy the content of quotes.txt into a new file.
The folder the destination folder thesis is not in that path. If you've done an ls there is no thesis in that path.
Oh, that absolutely makes sense. That is such a good point. That's a very good point. So, yeah, Dave, that's brilliant. So what we've just attempted to do is we've added thesis / quotes.txt, whereas we're already within that thesis folder. So it's telling us that within thesis, there's no other thesis folder. That does make sense. So hopefully, if we try it now, it should work. Quotes.txt. And then no thesis in front because we're in the thesis directory. But now we can't use quotations.txt because I had touched and created one already. So we would use copy quotes and see whether that works better. Yes, nice. All right, hopefully that wasn't too messy and confusing. Thank you, Dave. And so what we've done is to take the content of quotes.txt, a file, and then copy that over into a new file. Originally, we ran into problems because we had stipulated the paths, including thesis, but hey, we don't need that because we're already in the thesis directory. Right. I'm going to ask you to copy quotes.txt into a file of your preferred name and see whether that works. Remember using this copy and then, okay, I think it works for Sylvester, and then add your name txt and see whether it works for you. Okay, Obi has a challenge. Do you want to share what that is? Okay. Think Obi, do you want to go into a breakout room with I don't think we have permission to go into breakout rooms.
No, but I could start a meeting with like a separate Zoom meeting. Should I do that? And then I can discuss quickly with Obi and we can come back.
Yes, that sounds good.
And then you
Thank
can
you.
carry on in the main one. All right,
Yes.
I'll do that.
Thank you so much. All right. And if anyone does have a challenge, please feel free to speak up.
So, sorry, please, how do I do it? I'll send the link 1 second. Okay.
Okay. Thank you, Obi. Thank you, James. And yeah, so we're going to experiment with moving entire folders. So copying entire folders. We've done this with a single file, but we want to make a copy of a full folder. So if we wanted to make a copy of our thesis folder, for instance, we would still use that copy, but now we have an option to copy a whole directory. Yes, Sylvester has a hand up. Go ahead, please.
So before you proceed, you showed us how to rename a file.
Yes.
Is it a must we include the directory? Like, can I just rename a file using the mv command?
Yes, you can rename a file using only the mv command. So we had added the directory just to specify the path where it's found in.
Okay.
All right. So I went back in time to look at this command. So we only
Yes.
added thesis/quotes because we were outside thesis folder and we needed to target this quotes.txt file within thesis.
Okay. Thank you. So right now, like I used the example, copy _ quotes. I wanted to change it to the one you just showed us right now, your name dot something. So I was wondering if I should, yeah.
No, you don't need to. You don't need to state the folder anymore.
Okay. Thank you.
You're most welcome. And so to copy a full folder or full directory, we would say copy and say R. And then we say the name of the folder. So for instance, we want to make a copy of the thesis folder. We say thesis. And maybe we want to have a backup of this thesis folder in case something happens and we don't want to lose all our hard work. There are better ways to do it than having to create multiple copies, and we'll talk about that at some point. But for the purpose of the Unix shell lesson, to create that additional backup folder, we say copy -R and then thesis, then the new name of that backup. So let's say thesis backup. And it says, right, because we're already within this. I'm going to do two things. I'm going to step outside of thesis and run that same command. And it does create a copy of the thesis directory. And we can do ls to look at the contents of the writing folder. And we have that Little Women.txt, draft.txt, haiku.txt. And now we have thesis, but also a new folder, thesis backup. And so does that make sense. I'm going to give you a minute to try to create a copy of the thesis folder. And once you're done, you can let me know in the chat whether. Green check mark, messages in the chat so we know that you've done that successfully. Right, I see two dones, done. Just gonna give a bit more time for people to try that out. All right. If you struggled a bit with that, just let us know and we will clarify. If you try to copy a file or a folder that is non-existent, be sure that you would have an error because you cannot copy a folder that doesn't exist. Quick check. What would be the command to remove a file called quotes.txt? I'll let you answer that in the chat. To remove a file called quotes.txt. Okay, I see. I see an answer in the chat. All right. We touched this slightly before, but just to really spell it out, you don't always have to be explicit on the names of these files. If you're sure about the folder structure, you can save yourself a lot of time by using wildcards. So a wildcard is usually symbolized with this asterisk. And say we wanted to navigate into, oh, this is a good time to explain this actually. If we wanted to navigate into thesis backup, we could use thesis. And if we don't want to spell all of it, you know that there's just one thesis backup. You can use a wildcard to finish that sentence, right? So finish that particular command. So if you wanted to cd into thesis, now you're in thesis backup. Look, pwd, and you're in thesis backup. Whereas if you wanted to do it the conventional way, you would have to type backup and expose yourself to more keystrokes, it's better if you can save yourself time doing this. And wildcards don't also have to be used at the end. You can use them in the beginning. So if, for instance, I want to go into, we still say thesis backup, I could do this, and I try to find the file that ends with up. So I've got that cd command and the file that ends with up, and see what happens. And just like that, in fewer keystrokes, I've gone into the file that ends with up because I used that wildcard to say, forget about everything else. Look for the file that has this ending or the file that begins with this. It can get a bit tricky if, for instance, I say cd th and then I use I'm going to come out of this folder first. And so if I want to say thesis and then wildcard, how does the computer now know which of these two files I'm referring to? So that's why I say you do have to make sure to a reasonable extent that when you're using wildcards, you don't have multiple of the same thing. If not, it just confuses the shell. Let's see, string not in pwd thesis. It gets a bit complex. So far, we've looked at how to copy files, to make new directories, how to move with that mv command, how to delete or remove files. We've also looked at using wildcards to search, right? So we could use the asterisk and then .txt, it opens the only .txt file there, right? We've looked at the different types of extension names that files could possibly have. And we're now going to the concept of pipes and filters. We'll just chat a bit about this, and soon you'll be allowed to go on another break, but don't keep your mind on the break. Think more about the lesson. So pipes, what are pipes? How did we get to the subject of pipes? Well, you can combine commands to yield a particular output. And let me clear this up. Let me clear the terminal. I know that this is all a lot, but like I mentioned earlier, you don't have to memorize. You can keep this. Once you get the foundational idea, you can always Google how to do a particular thing within your shell. So we've looked at a lot of different commands today. It's easy to combine these commands if we do something. I do hope that you have this data file. So within your alkanes folder, this alkanes folder, we're going to try a small hands-on exercise and ask you to please open that up. Let me go back all the way. CD into exercise using that wildcard. And there we have the alkanes. So one of the new commands that I would like to introduce you to is word count. To count how many words are within your files. For that, we do have to go into an alkanes. I'm using the wildcards more now that you're familiar with it. And if you do an ls, you would see this file called cubane.pdb. So this is that protein data bank. Remember that our marine biologists had. So we want to sort through these files and count and know how many words are within each of these files. So we do that word count cubane. I've looked through to see that it's just the cubane there. You could do this word count cubane or type all the way WC space CUBANE.PDB. And it really does count for you. If we wanted to be super efficient and count for all of these files at the same time, then we can do WC. Remember, we talked about wildcards. You use the asterisk and count for every single file that ends with that PDB. And when you enter, you have all of it at the same time. So if you wanted to be super specific and not count only the words, but just count the number of lines in each of the files, then you could add word count, this option, and that returns only the number of lines in the files. Let's try something funny. What if we say word count and just that L? Yes, we have an expert opinion from Dave saying
Hello,
use.
ask your question because nobody's answering me. Can I ask?
Yeah, Opit, where did you leave your question, please?
Okay, that other one, I'll take care of it later. I just decided to continue. Like you word count on this Cubane.pdb. What does that 20, 156, and 1158 mean separately like that?
Great question. So we're counting lines, we're counting words, we're counting characters within the file. So if you were to open that file normally, this is how many lines you would find inside.
So the first one is lines.
Yes, and then it
The
counts
second one,
words.
words.
Yes.
And the last one?
It
Character.
counts characters. Yes.
Okay. Thank you very much.
You're most welcome. You're welcome.
Can I ask? Hello?
Yes, please go ahead.
As you stated that it's has the other one is lines, the other one is words. Is it the setup? Is it for every document? Is it like that? Or
So if
am I gonna find sometimes it's switched around the lines goes on the other column?
Okay, if I understand you correctly, you're asking whether this would be the same no matter what file you're looking at. So whether it would still count the same.
Yes.
Great
No,
question.
not the count, but I mean for the names of the columns. Is it constantly like that?
Oh yeah, I'm not sure. I'm not sure I understand your question.
I'm asking not regarding specifically to the values. I'm asking if the names of the columns will always be like that. It will be lines. It will be word count. Yes, number count, like that. So on.
Okay. I think I get what you mean. So would it still count in the same way, no matter what sort
Yes.
of yes, okay. Yeah, that makes sense. So yes. It will count lines, it will count words, yes.
Okay. Can you repeat first row their names again, please? It's
The names of
You said it's lines. The first one is the first column is
oh
lines.
yes, so it counts lines, it counts words, it counts characters.
Okay, thank you very much.
Yes, you're most welcome. Okay. Yeah, so if we attempted to do word count and just use that option to count lines, then nothing would happen. So all the while we've been talking, nothing has happened and nothing will happen in reality because you're just saying word count. You're not asking it, you're not giving it a specific file
I
to.
still have some questions there. Sorry. I hope I'm not interrupting you so much. Yeah, I checked it. I'm using Linux, I checked on when I listed exercise. I think some of this data came up. I did the listing and it came up with alkalins gave me maybe the total of 4,096. I don't know what that one is, and it gave other parameters, but I don't know. But there's this one that is 4,900. I don't know where they are coming from. I don't know whether you understand what
Maybe I'm not sure I exactly understand, but I think what your shell has done is to read the actual content of the file, maybe. Because I'm not sure where those numbers are coming from.
Okay. Maybe I'll investigate further later. Thank you very much.
Awesome. Yes, you're welcome. And yeah, so we were just mentioning that this command in itself will do nothing for you. And all right, so something else that we could do racking my brains to really try and find the most necessary parts of a lesson for you. Okay. So if we wanted to count all the files that we have within this directory, all of these alkanes, and compare to know which ones are the longest or which ones are more packed with a lot of data, it's something that we could get through right here in Unix. I'm sorry, there's a question in the chat. Trevor says, how do I get back to the prompt after running the command, which ends with L? Exactly where you, oh, great question. That's where I am as well. And yes, we're stuck at exactly the same place. So that's good. That's fun. At least we're not alone. And typically I would break out of this using Control or Q. Evidently, neither one is working. But yeah, okay. Control C does break that. And see if it works for you. Control C. Oh, exactly, Dave. Thank you. Control C does break us out of it. Nice. Right, balance is restored. Now we can look a bit more at these files and look at how to examine the lengths of files. It's easy to do this when we have just 6 alkanes, 6 files containing information on the different alkanes. But what if we had maybe 10,000 of these files? It would be hard to do that. And so we can tell our Unix shell to do the same counting activity, but when it does the counting, it should move it into a specific file. And this is a longer command, but if you follow it in step, so word count in that option L, using the wildcard to select all the files in this protein data bank, and use this caret like a greater than symbol and put that into lengths.txt. So this greater than is basically saying, instead of printing the information to the screen, take that information and put it into a file called lengths.txt. See? So if this length.txt file doesn't exist, it goes ahead to create a length.txt file and puts the information we're asking for into that file. But if it does exist, if you have a length.txt file, it's going to overwrite it like entirely, wipe it clean, and then put this new information in there. So we've done that. And now we can confirm whether that file really exists. And we say ls lengths.txt. And it's right there. So that shows us that we do have the file. And for us to, sorry, excuse me. Maybe it's worried that all the information is going down to the bottom of the shell, but I also don't want to risk clearing it. So I'm going to clear in any case and ask that if something doesn't make sense, please just call our attention to it. Okay. And so what we've done is this command to count, but then count into a file. We've also confirmed that that file now exists. So we take the content of this file and we want to show it on the screen. We want to essentially read that file. We want to open it. So we use this command cat when we want to open that file, lengths.txt. And that cat is short for concatenate. So we want to, we've taken the content of length.txt and we're showing it on the screen. So it's counted the lines of all those files. But
It's
instead of
13 hours.
instead of putting that on the screen directly, we put it in this file and then we can read the file separately. All right. So we'll look
Hello.
a bit.
Can I ask?
Yes, please.
If I want to filter the information on the file, like it starts from the smallest number to the biggest number. How do you know how to do that? Is it possible?
Yes, so it's getting a bit hilarious how the questions always lead to the next part of the lesson. So that's
Oh.
exactly what we were about to start talking about, how you could filter the outputs or sort it, as you said.
Okay, thank you very much.
Yes, you're most welcome. And
Remember, could you go a step up before you get that length text?
you mean to this command?
Okay, yes. So you are copying all this other thing into or what? I don't understand what's the actual thing you did there.
Okay, great question. So this is that same command to count, word count.
Yes.
And yes, so we're saying count the lines, right? Count the lines of all the files that end with PDB. So that's this wildcard dot the PDB. But rather than just have it printed onto our screen, we want to take the information and put in a file. So that's what we did here with this greater than sign. We're saying everything that comes from this part of the command, take it and store in a file and let this be the name of that file. So that's how we came about this length.txt file.
Okay.
And to read that file, we did cat and the name of the file, and that's how we got all of this.
Okay, I now understand. Thank you.
Thank you, Obi. Right.
Hello.
And so to talk a bit about filtering, to filter our outputs, we can sort the length of this file, and this actually introduces us to the sort keyword. Let's do this. Right, so we're back here. So this is that sort word, right? And if we want to specify whether we want like a number-based list or like a numerical list instead of a list that has both alphabets and everything, so we can say sort n, that gives us only numbers, nothing else. And we say the name of that file without any mistakes. lens.txt, sort n, lens.txt. And this is what it outputs for us. If you notice something really special happened. Methane that used to be at the third spot moved all the way up because we're sorting by the numbers. Do you see now it goes from the smallest number down to the biggest number. So we're sorting the files. Normally we would have to open these files, click one by one, count all the lines, and then know which one has more information. But in a matter of milliseconds, it's done that sorting action for us. And has anyone tried to do this and did it work the way it was expected to work for you?
It worked.
Yes.
Nice.
Yes, that's what.
All right. All right. And similarly, let's see. Right, Dave says it works fine. That's good to know. Similarly, we could do this command, but move it into a new file. Remember how we stored this counting in the first place in this file called lengths? We can store this same output, the sorted one, into another file called maybe sorted lengths or ordered lengths or ordered lists, whatever you choose to call it. So we repeat this exact sort command, this very one here. But this time we put that greater than sign to say, take everything from this command and put it into a new file called sorted lengths, right? .txt. That extension lets you know where you want to put it. And if we do enter in ls, we see that we do have the sorted lengths file. And within that file, you have this organized sorted list. If you wanted to check the first line of this file without having to open the file, you could very easily say head n, right? 1 sorted lengths. This does slightly look a bit more complicated than what we've been doing with just the cd command, but with time, it becomes more natural to you. So the output of this would be 9 methane. It's showing you the smallest number because that's what you asked it for, right? This part, you asked it for the smallest. You said, find the first line. If the first line of this file were to be 21 pentane, then it would output pentane, but the smallest there is methane. And so this is how we would take information from one place and then put it in a new file. Now, I want us to attempt writing more information into our own file. I want us to go all the way out. And within that shell lesson directory, we could create our own new file and write into it in a single command. This is how you would create a file and write into it. Remember, creating a file would just be touch and then the name of the file. But we can write directly into a file that we're creating. We can do that by saying echo. Echo is that command to write. And whatever text you want to go inside your file. So for instance, hello. You want to write hello into a file called greetings.txt, right? If we do that ls, we see that there's a new file called greetings.txt, and the first line of that file is going to be the word hello, which is what you've written. Take a moment to try that and see whether it works for you. Okay, so there's a question in the chat about what that echo means. So it's like screaming, I would say, just to use that echo. It's like saying into a file, hello, and then the word hello gets written into that file. So when we say echo, we're saying write hello in greetings.txt. Write hello into greetings.txt. And it does create a new file called greetings.txt and writes into it. Yes, Obi has a hand up. Thank you. Go ahead, please.
So why did we go back to shell lesson data before implementing this command?
Good question. So the idea was just to try and keep that alkanes folder clean. That was the idea, to not put a new file in there, but absolutely, if you run this same command while in alkanes, it would work.
Okay.
Thank you, Obi. Okay, what other questions do we have? Obi, do you have a different question, or did you forget to put your hands down?
Is it okay? Sorry.
That's fine. Okay. And with all of this, we have so many possible things that we can do with it. And so in the next 15 minutes, I'm going to try and show you how you could combine multiple commands into one. In theory, we've been doing that already. We've technically been doing that already by merging sort and n and all of that. But I want us to experiment with something. Let's go into we're going to try and get us back into this exercise data file, because I want us to look at something in the alkanes that we sorted. The alkanes. And while we're in the alkanes folder, I want us to try and combine that action of sorting the file called lengths.txt and outputting the first line of that file. So while we're here in, remember we had done sort and n lengths.txt, right? We had done this, but we tried to put it in a different folder, in a different file rather. But what we want to do now is to see how we can combine using those pipes that I mentioned earlier. So this is an example of that combination, that pipe. This vertical bar is how you would do two things or multiple things in a single command. And so each one will be separated with that vertical bar. And now we say head and 1. This might look familiar because we did that earlier. Head and 1 of the sorted lengths. So what we're doing now is combining the action of sorting this lengths.txt file. This is the content of the length.txt, if you remember. just this. This is the content of that file. And we want to sort it and still output the first line at the same time. That's the function of pipes. And if we say enter, it's returned methane.pdb. I will clear this terminal and just show you where we are currently. Remember, we're in that alkanes file, and the content of that file is all of these alkanes, and the length file that we have. Remember, we counted and we put the number in the length file. So now this command lets us sort this length file and at the same time get the head. That's the first line of that file. And it shows us that 9-methane. If we didn't sort that file, if we just printed the head of that file as is, it would give us the first line, which wouldn't be the highest. So let me show you what I mean by that. And the txt. This is the content of that file. Normally, heads N1 would give us 20 cubane. But we sorted it in increasing order of these numbers, which meant that 9 had to go up. So this is just it's an easier way to do many things at the same time by separating each action with the pipe. And I'll pause here and ask whether we're fine. Are we good? Have we lost anyone? Does anyone need something clarified before we go on?
Can I ask?
Yes, please.
Regarding the creating the length file, I see that it gets created in the present working directory that we are working on, or yeah. So if I'm in a certain folder and I want it to be in another folder which is different from the current working one, how do I do that?
That's a really good question. So we use this command word count and L to count the lines, specifying with the wildcard PDB to say count in all the files. And then we put it into this file directly and we said length.txt. If we wanted to put it in a different file, then we would have to specify that new path where we want it to go. Do we want it to go one step outside and then in a folder called thesis, and then in the file called new file .txt, you would have to specify it to that degree, right? If you wanted to put it somewhere else. We didn't go as far as adding a specific path, so it just put it in the present working directly, because we did this lengths.txt, right? So it gave us that file within the alkanes directory, but we could definitely specify to say, okay, create this somewhere else by just adapting that path here. Does that make sense?
Yes, thank you very much. I understand.
Yes, you're welcome. And this is the idea of pipes being able to do so many things in one swing. It's not only 2 commands you can put, you can do 3 commands. So remember this WCL, word count L, wildcard for all the PDB files. We did that command, but we could put a pipe like this and then say, sort it numerically, and ask it to give us the head. We could do all of these 3 things at the same time, and you might already guess that it would output that methane again, because it counted, it sorted, and then it found the first line in milliseconds. And so that's the central idea. So far, we've been able to cover counting lines, words, and characters in files. We've also learned to display the content of files using that cat, which is like short for concatenate. We've also learned how to sort in increasing order. We've also learned to use the head command to show the line at the top, right? We can use it to show the line at the top. We can also use it to show like the first 10 lines. If we were not as specific as saying head and 1, it would show us the first 10 lines of that file. If we had just used only head without specifying to say, okay, make it numerical and count only the first line. So we've learned how to use head. And there's a command that's tail, which you might guess from head and tail that it does the opposite of what head would do. So it shows you the last 10 lines of the file. And we've also learned how to take a command and direct it into a file using this greater than and put in the file name, right, where we want that command to go into. And we've learned how to separate different commands using pipes, and so that we can execute them all at the same time. We will take the last couple of minutes to we will try and just assess whether from everything we've discussed all morning, shell related, what questions do we have? We won't go into too much details about this, but I will mention one of the most powerful features of the Unix shell is its ability to iterate. So iteration is essentially going over things or looping over things. You can write actions that repeat themselves using your command. So if you had a list of fruits, for instance, you could write shell commands that will go over the list of fruits and do a particular thing. So go over this list of fruits and get me all the fruits that start with G. So get me grapes, get me guava. I can't think of another fruit that starts with a G, but that's the idea behind loops. So why would anybody need to write loops or even use them in the first place? Well, loops save our life because they help us to repeat commands. We program our shell or any computer. Loops actually apply to a wide range of activities. So, but the central idea is that they help you to repeat action without you having to mediate or interfere with those actions. We were going to have to point you to some more resources for Unix, and having the foundation that you do now, we hope that, so the idea of the workshop is not to get you through all of the information, but to give you a solid enough foundation to get started. And if you get stuck, now you know how to Google better, you know how to ask questions by virtue of having sat through here for what, 2 hours plus. I really celebrate you for, oh yeah, it's way more than 2 hours. I celebrate you for sticking through till this point. I'm going to give you a minute to breathe and then see whether you have some more questions before we go on lunch break. All right. If you think of a question during the other sessions, please feel free to ask. It might be helpful to write them down, and then maybe towards the end during the wrap up, you can ask some of the questions relating to Unix. But when we go on break, we will go on break for 30 minutes and then come back. And after the break, we will start talking about something slightly different. We will talk about Git, which even if you haven't heard about Git before, it will present it to you in a way that you would, in a couple of hours, be able to teach someone else about Git. But for now, we're actually going to release you to stretch and hydrate. And James, do you have a word before we let people go?
Just thank you, Deborah. I agree. That was a really great session. So thanks a lot for that. We come back in half an hour, right?
Yes, exactly.
Super. Cool. All right. See you guys in half an hour. Thank you, Deborah.
You're welcome. See you. All right. Welcome back, everyone. If you're here, could you please let us know somehow using a thumbs up, a reaction, or some green check mark, a comment in the chat. And nice. It's good to have some people back. And there's been a lot of information thrown at you today, but I hope that amidst all of it, you did get value out of it and you feel more confident about using that Unix shell that we discussed. And for the rest of the workshop, just the next 1 hour or so, we'll look at something a bit different, and that would be Git. I do hope that you received setup instructions for this as well, and you have Git installed. Otherwise, we will do that together using the command line. I'm going to start my screen share now. Share that terminal. I'm going to ask you to check that it looks fine for you. It's not too large, not too big.
Yeah, I can see maybe a bit bigger.
Yeah. There we go. How do we feel about this size? Right.
Yep, I can see. That looks good.
All right. So yeah, like before, setup instructions are, I'm going to share setup instructions. Actually, James, can I please ask you to share those setup instructions?
Yeah, of course. I'll post them in the chat.
Thank you. So we're going to get started with Git now. And you might be hearing Git for the first time. That's fine. But as the lesson unfolds, you get more used to that idea behind Git. Why was it even vetted in the first place? So we're following along with the story of two people who have been hired for their culinary prowess. They've been hired at a restaurant and they need to achieve a best recipe. They want to make one of the best recipes. But they've run into some problems in time past. If they take turns at trying to make that dish, then each person spends so much time doing the work. But if they want to work on copies, they would have to exchange emails back and forth. Imagine trying to do this with someone, trying to make a meal. Someone is in Africa and someone else is in Uganda. You're trying to cook the same meal. You would definitely run into problems. And this is why we come up with this idea of version control. So version control essentially helps take away that stress of having to go back and forth to explain what you've done, what you've put in the meal to the person. It leaves that very nice dish at a particular stage, and it's easy to go back to a previous stage. If someone accidentally put a bit too much salt in the dish, you can go back to a time where there wasn't that much salt in the meal. And it's easy for two people to be working on separate components of the same dish. So someone is slicing carrots and the other person is making the sauce. You're all contributing to the same projects, but you're doing it as at a pace and in a way that's more collaborative. And this is why version control was born. At this point, you probably have a GitHub account already. And if not, we're going to ask you to please go to github.com and create that account of yours. The instructions will be where James has put in the chat, but this is also that link to github.com to create an account, follow the instructions, and yeah, using your email, set it all up. So right now we have a fair understanding of shell. And so it's easier for us to follow this lesson about Git. So another example of how we would picture Git and version control is if you were doing a master's thesis and you made one single file for your master's thesis, you wrote in that file, but you want to send the latest version to your supervisor. And after your supervisor makes some changes to that file, you can create another file. So you can save all the changes in a new file. Maybe you call that revision1.txt, and you send that over to your supervisor and they ask you to make some other change to it, and you have a different version out of that. You end up with like 10,000 different files, and that's not very efficient. But with Git, you can save the history of that file. You can track it so that every single change you make is effectively accounted for. You can have the same file, but many different versions of it. And every time you make a change to that file and you save it, what you've done is you've created a commit, right? You're committing. So every time you do that Control S, you're making a commit. And we're going to show you how you can attach a commit message to every single action of save, right? And then we have the idea as well of repository. So just going over some vocabulary that you might hear during the Git lesson, you will hear about repositories. So repositories are just folders. They are folders. Think of them as your project, your whole thesis project. You could have within that one repository, you have a folder for your data, you have a folder for all the dependables that you're using to analyze your data. In a different folder, you have all the literature material that you've reviewed, all of them stored. So they are kind of like folders that you would have on a typical computer. So if you have ever worked collaboratively with people on a single project, I'm actually going to ask you to put in the chat what sort of problems you encountered when you tried to work with people on the same project in a single file, maybe like a document. What sort of challenges do you normally run into when you try to collaborate with people side by side or in parallel? Feel free to type a response in the chat or otherwise. Off the top of my head, I can think about time zone issues. So if I wanted to work with someone in the US or in Canada, I would have to be awake at my bedtime, or I would have to make them be awake at the wrong time. There's also the problem of too many versions. There's always also the problem of conflicts. Imagine writing into the same file at the same time. I might be writing a perfectly logical sentence. I don't know whether you've experienced this during Zoom calls where there's a shared doc. Oh yeah, so people could, this is such a great point. Someone has put in the chat that people could accidentally delete your recent updates by mistake, like without any knowledge of it. That's such a good point. We're on an online Zoom call in a HackMD or whatever file, and people are all trying to fill in the attendance at the same time. I've seen this happen so many times. They're trying to fill in the attendance at the same time, and you start writing, but then you see someone typing over your name. These are the sort of problems that happen when people try to collaborate at the same time. And over the course of the next hour and tomorrow, you get to find out more about how Git or version control in general solves this problem. So for now, we're going to configure Git, or basically set it up. And the first things first is to open your command line. If you have your command line open, you can check what version of Git you're using by typing git --version. And so come here and say git version or git v, depending on what OS you have, and let us know if you have that installed. Thumbs up, check marks if you have that installed. Do we all have our Git version being displayed on the in the terminal here? Do we have our Git versions displayed? So I've got Git version 2.4. Yeah, okay. I see one thumbs up. And another. Thank you, Sylvester. Thank you, TG. Okay. Yes. So David has a 2.44. All right. So we're going to try and configure Git. So Git needs to know which username it will operate on, right? So who will be the user of this particular Git? So if it's like, if you wanted to create a Blue Sky account, of course you need a username and an email attached to that for as part of the credentials. So you would do git config, that's the command, and user.name, and then have this quotes to put your name in there. So git config, user.name, and I have my name in there. It does not in a Git directory. Oh yeah. So I'm in a place where Git doesn't technically exist. So it's telling me that I am not in a Git directory. Do people have similar problems thrown at them when they attempt to do this? By the way, I should probably go into Echo shell for the purpose of this. Yeah. Okay. Do people have their Git username configured? I do already have Git set up. Thumbs up if the configuration works for you.
Isn't that's supposed to initialize the folder as a Git repository first?
Oh yeah. I think I should swap places with Dave. By the way, if you struggle at any points to hear me, please let me know, because it started raining where I am. I can't complain because I love the rain. And so do we have that all set up where we are? No. Hello, sorry. Sincerest apologies for that. The rain is good, but with it comes bad internet. Checking that you can see my terminal.
Yeah, we can see.
All right. And so, yeah. Before I disappeared, I was asking whether people were successful in configuring Git. Okay. And so I've configured the username, and I would do the same with the email, but I won't go as far as typing all of that. So user.email, and then you can add your email address in here. So with that, I've set up this environment to use Deborah Udo as the username and that email as the preferred email address. If you struggle with any of this, please let us know. So with every command, that enter or return allows you to enter as we've done all morning. If you have a preferred text editor, as we mentioned earlier today, we use a text editor called Nano. If you have another text editor that you prefer, you could also configure that directly and say git config, for instance, global, and add core.editor and go ahead to put in here whatever the name of your preferred editor is. I quite like VS Code, and so that's what I use. Yeah. And so if I wanted to use VS Code, that I would put in here code. And that's that. So in the same way, remember earlier when we did the shell, we were able to run ls and run the help command or help this way. Similarly, you can look at git config and help. This gives you a list of all the different things that you can do with git config, the different configuration settings that you can have. And if at any point you wanted some more context around the commands of git, you could do git help, and it gives you a list of all the commands that you can use. So clone, init, add, mv, restore, remove, that looks familiar, bisect, diff, grep. So all of this, you have a full list of help commands. And having installed our git, we can go ahead to create a new repository. Remember, we said that that repository was just a different name for like a folder to house each project. So how does Git really store your information, and how can you use a Git repository locally? Now we're going to move into our desktop. Let's just cd into our desktop. pwd to confirm that we're really in our desktop. We want to create a new folder called recipes. What would be the command to create a folder called recipes? What would be that command to make a new folder, a new directory, to make a directory called recipes? If you guessed mkdir, recipes, then you guessed correctly. So you make a new dir called recipes. And move into that recipes. If I didn't want to type all the way, I could just use my wildcard, remember, to go into recipes. And now if I do pwd, I'm really in that folder called recipes. So to tell Git, which is that software, to start tracking a folder or a repository, we need to explicitly say, hey, Git, I need you to start tracking this. Because as much as you have Git installed, Git isn't going to track all of the files and folders on your computer. It's not going to do that unless you ask it explicitly to track things. One of the ways we can, the way we do this is using the command git init. So we're saying, hey Git, initialize a new repository. Start tracking this repository. And if we enter that command, it tells us many other things that it should not tell us. But now we have, yes, Sylvester, that is good.
So I have an issue. I
Okay.
think I mistakenly typed something. I was trying to press, I don't know how you call it, the button below the escape button.
Oh yeah, the child.
Yeah, so I don't know. It's like an apostrophe, then / desktop, but now it's gone to another mode. It's written B quote, and I can't go back to the base. How do I go back to the base?
So if I understand you correctly, you type this tilde sign, and
Yeah, but
it took you.
it didn't display that sign. It displayed an apostrophe, and I didn't.
Oh
Yeah.
yeah. Okay, okay. And then it took you somewhere
But
else.
yeah,
What path are you in? Could you do pwd and see where you're in currently?
I've tried doing it, but it doesn't work. It got to a point like it's, you see the brackets called bases, the brackets right
Yeah,
below.
yeah.
So right base, it's B then quote.
Maybe if you paste that in the chat, James, could you
Also,
help?
Yeah, if you put it in the chat, I'll have a look.
Okay.
I was trying to go back, so that's the problem. Okay, let me just copy it.
Okay. So we've initialized. If you've done this successfully, it should say initialized empty Git repository in. It tells you the path where you've created that Git repository. Now, if you do ls, you don't see anything. If you do ls in here, and say, a suggestion, Sylvester, would actually be for you to close that terminal and see if you restart, if that helps. Okay. So we've tried to do ls in this recipes folder. There's a new file, but it's not showing up. But remember, today we talked about a command that lets you see even the hidden folders, that command that lets you see all the folders. And that option is the -a, just -all. And now you see this new folder that wasn't there before. This is the .git folder. And this folder has the power to track every change that happens within your recipes folder. That's the power of this command, git init. So initialize an empty folder that will track all the changes we make in recipes, right? ls won't show you that because typically hidden folders are those folders that begin with dots. So dots, anything, dot, as long as it starts with a dot, it's most likely going to be a hidden folder. So we can't see hidden folders using the ls command. We have to do lsa. So we see that git directory. Now, if we type this command, git status is going to say, yeah, you're on the branch called master. For you, it might be called main. You're on the branch called master, but you haven't made any commits yet. You haven't made any changes. You haven't saved anything to that recipes folder since Git started tracking it, right? But we can do so much with just this new folder here. For instance, that folder is going to track every change you make within the recipes part. So we're going to experiment with this. Let's try to experiment. I'm actually going to ask you what this command git init means. In your own words, what would you say that git init means? What does it do? Feel free to type that in the chat or just unmute and tell us, just put your hands up and you can tell us what you think git init means or what it might do. All right, so we're activating a new Git. So this command essentially tells Git to start tracking the contents of a folder. Fantastic. Now we're going to look at how Git records changes, how it knows the status, how you can tell the status of your files or folders within this recipes directory or repository, right? Why we even need to make those changes in the first place. So we're going to make a new file called guacamole, right? We can make this is the so we want to write about the recipes for this dish or this side guacamole. But to create a file, do we remember the two ways that we talked about to create a file, whether you want to just create the file or create and open the file using a default text editor? What were those two ways that we could create a file? Fantastic. So we can use that touch, right? Guacamole.md. And we talked about extensions, right? This is a new extension. We didn't do .txt, a text file. We're creating a markdown file, which is quite similar. It lets you just write text, but with markdown, you have the flexibility of adding some styling to the text. So that's really convenient. So we can do touch guacamole, or alternatively, we can do nano. Guacamole is a really hard word to spell. So we have nano guacamole, and it opens it up in this nano tab. We want to write some text into this file to sort of see how Git tracks files and changes we make within them. So we will write hash guacamole just to show that this is the recipe for guacamole. But take note that that hash is not like a special command. We're just writing in a new language called Markdown. And in Markdown, you can write different headers, different sizes of headings. In the same way you could write header 1 in a Google Doc or any other document. Markdown allows you to write in different semantic headings, or headings that have unique meanings or different sizes that indicate what they mean. So guacamole, and we come to the next line. We write a smaller heading that's ingredients. I did see something come through in the chat. Let's see what that is. Yes. David's also wondering why I chose the word guacamole. I know how random it sounds, but we were talking about two culinary experts who were hired. So I think it's only fitting that we use something food related for our example. But feel free to use a local dish that's more suited to your dialect. And the ingredients could be, avocados, and if we're making a list item, we could do that instead. Black peppers. That's it. And of course, no dish should be made without love. So that's the biggest ingredient. And we've now written into this file called guacamole. Thank you, James. So there was a question asking how we got into this particular window. So if you do nano and guacamole.md, it creates that guacamole file and opens it in the nano text editor. And so we're writing into this file a recipe. And if we save this file, and hopefully, just hopefully, it agrees to save this time. If it doesn't, I will shut down my terminal and run away screaming. And Git is able to sense that we've made some changes to that recipes folder. It knows that we've made changes to the folder. And yes. So we've done some things to that guacamole file. We've added text into it. Now we're still in recipes. When we do ls, there was nothing in recipes before except that .git folder, but now we have guacamole.md, that file that we just created. If we want to see all the files, including the hidden ones, okay, Sylvester, please go.
So I'm just wondering how you managed to save it and then go back, because I didn't see that
Okay.
step.
Yes. So the command is the same as we tried last time. Great question. We do the Control and X. I did Control X to leave there, and it asked if I wanted to save it as guacamole.md, and I did enter, and it worked. Then we have to ask the question of why it didn't work last time.
Yeah, it
So
stopped.
yeah, awesome. So it's all sorted now, and if we list the files in recipes, we can actually see that our recipes have been added per our expectations. But we want to look into that guacamole.md file. Remember when we had that length.txt file and we wanted to open and view the contents? We used this command cat, which was like concatenate. That's the same thing we would do for the guacamole.md. So we want to see what's inside of it. And it gives us this nice little list. In hindsight, I probably should have cleared the terminal before getting this far, but worry not. I'm going to clear and do exactly everything that I did before, so you can see it. So I had just listed all the files in the recipes directory, and I had done cats to open that guacamole file, and we see all the ingredients for making that. To know that indeed we wrote into that file and we save it. So if we do that same command, git status, remember the first time we ran git status, it said nothing to commit, you haven't made any changes yet. So if we do git status now, we see a different message pop up. It says no commits yet. That's true because we haven't saved anything officially to Git. And we have some just one untracked file. So anytime it says that you have an untracked file, it means that you've added something new. You've created a new file in that folder where Git is tracking. And that file we created is guacamole.md. Can we see that? So to add this new file to what Git should keep tracking consistently, we do git add. Remember that when we initialized that GitHub, that Git repository in recipes, we didn't have any files. Now we have a new file and we need to tell Git explicitly. So add this to what you're tracking. Sylvester, you've actually typed cat apostrophe guacamole.md. So it says you don't have any file or directory named guacamole. Could you do ls and see that you actually successfully saved that guacamole file? And then try cat again if it's saved properly.
It shows it's saved.
So if you do the ls, the guacamole file is there. So when you
Yes.
do cat and you confirm that you're spelling it exactly the way that you save that file.
Hello?
Oh, yeah, sorry, I mistyped guacamole.
That's not very surprising. It's a strange word to spell. Yes,
Yeah.
Obi.
Oh,
Yeah,
thank you.
there's no extension on my own. I don't know why.
How do you mean?
I did a list. Well, it didn't give me any extension.
So when you did your ls, it didn't give you any files whatsoever.
It gave me a file, first dot, second dot, the second place dot, then .git, guacamole,
yes.
but there's no extension like MD.
Okay. So it means that you saved your file, the file you created, you had created it as just guacamole without the .md. So the file you have now is
Okay, so I
only.
have to add it. I thought it will save automatically.
So if you had created the file as guacamole.md, it will save as guacamole.md.
Okay.
But
Okay.
if for some reason, maybe you had left out that .md, it's not going to save.
Yeah,
It's not
I didn't add the .md.
exactly. So if you remember from our Unix lesson, you could attempt renaming that file using that mv command, and let's see how that goes. If that sounds too complicated, please feel free to use the normal graphic user interface and just add the extension .md to it, and it should be fine. All right, so to tell Git to add this new file to the things that it knows to track, we say git add, and we type very carefully that word guacamole, adding the extension git add guacamole.md. And when we do this, we've told Git to track the file guacamole.md, right? Another way we could have just done that, and you probably will start doing that much later, is to say git add dot. So this is just saying everything that's present within the recipes folder, start tracking it all. This might not be the best approach when you're just starting out, because you might not want to add everything explicitly. And yes, Dave, please go.
Yeah, just want to make a comment on the issue of, say, for example, you're writing the command git add and you start typing guacamole. So I was saying that if you just start typing like GU and tab, basically it will tab complete any word which matches that those starting characters. So it kind of helps sometimes that you don't have to type the whole thing, as well as you don't make any typos.
Nice. That's a very good tip. Thank you, Dave. Especially when it comes to spelling words that are quite easy to miss. So when you start spelling GUA, and you can use the button that says tab right under the tilde button, that one that says tab, to auto complete it. Thank you, Dave. And so now we've added guacamole.md to the list of things to be tracked. So let's run that git status again and see what that command might output this time. And it says no commits yet. That's true. But there are changes to be committed. Notice how slowly the words being shown at you are different. See, so before it started out with your on branch master, no commits yet, and then it said untracked files. Now it doesn't say untracked file anymore. And why might that be? So we've told Git to track the file by doing git add and then guacamole.md. So now it's giving you a different option. It's saying, oh, hey, you have changes to be committed. Git wants you to store this new change in its memory, so it has it forever. And this time it's not red. The file that you need to add becomes green to show you, oh, I'm tracking this file, but there are changes that we need to commit. But if it's red, just know that you haven't really added that file yet to be tracked. And so we have a special command to commit files to Git's memory. And that command is very conveniently called commit. So git commit, but you have to write a message. This is so important. You have to write a message every time you commit or save a file. Remember that your thesis file where you had a couple of corrections to make from your supervisor, and because of that, you created a new version of the file. And when new corrections come, you create a new version and you say corrections from day one.txt. That doesn't help you in the long run, because if you want to go back to an exact version of that file when a specific change was made, you can't see that. But with commit messages, you're saying exactly why you've made that change or what you were trying to achieve with that change. And these commit messages should really be descriptive, so that every time you see that commit message, even without looking at the version history, you know exactly what it is you did. So if you're working on a website, for instance, and you've added the website logo, the commit message should have something related to that website logo, so that you know that that was what the change is about. So if you need to change that logo to a different one, you know exactly where in the history to go and find that information. So git commit, and then that M option lets you put in a message. And you can't just go ahead and write your message. It won't understand it that way. It's more appropriate to put your message within these quotes, right? And then you can put the message. And this time we'll just say, maybe added 3 ingredients to guacamole recipe. So every time you come here, you remember. And if you want to make it even more descriptive, you could say added the first 3 ingredients, because in the future you might want to add exactly 3 ingredients, but those ones won't be the first 3, right? So that's how specific we want to get with our commit messages. But on the other hand, we don't want to have like an entire paragraph in the commit. We want a short commit description. And if you wanted a more detailed description, you will get to find out how to do that soon enough. And so we do enter, and we get a message. It says master root commit. So it gives you this number. This number is so important. We don't think too much about that number, but if we ever needed to go back to this specific commit, this number would be the identifier for this one change that we made. So all commits come with a unique identifier. It blows my mind how so many people can use Git, but then never have to use the same identifier. It's amazing. So it gives you this unique identifier, which will be different when you do a different commit. And it shows you the message which you used. And it says 1 file changed. Yes, indeed, we changed one guacamole.md file. We added 6 lines. So whenever you see this plus in Git, it's additions. If we were to remove some lines from that recipe, maybe we didn't want to add love as one of the ingredients, it would say that there was one deletion. And so this is all for guacamole.md. I will pause and ask what questions we have about Git, Git add, Git commit, the commit message, nano, or anything else. All right. And so now when we type git status, that message changes again and it says you're on the branch called master. There's nothing to commit. Everything is clean. Your working tree is clean. It means all the changes that exist, you've already tracked them in Git. You've saved it in Git's history. And if you want to easily access all the changes or all the commits, you could use this command, git log. So a log is essentially like a history. Just show me the history of the changes that I've made in this repository. And it shows you this. My goodness, look at this. This is the longer version of that identifier that we saw earlier. See, F235362. So that's the longer version of the identifier. It shows you that the author of this was Deborah Udo, and Deborah Udo with my email address. But for you, it will be someone else. It's going to have your name or whatever credentials you use to configure Git, and it shows the exact time and date when I made those changes. This is so helpful. You know exactly when you made the changes to your file. But think of how this could get more complex when you've made like 1 million commits to your repository. In the future, we're going to show you a much shorter way to sort things out, get things done. And yeah, so if we wanted to make some more changes to that file, we could go back to this guacamole.md file, attempt to make changes, add a new line to that file. Once you add a new line to the file and you run git status, then it shows you that you have changes that should be committed. And in 2 minutes, I will just open that same file, attempt to add something, save, and then come back here. So we run git status and see how this works. You could do this with me to get some practice as well. And then we will leave the last 5 minutes or 4 minutes or so for questions or any other instructions about tomorrow. So I will clear this terminal and yeah, I don't think it's feasible to show you that and then come back in 1 minute. But what might be helpful is showing you how to do a git log one line. So we said that a git log shows you all of this, but a git log one it shows the it shows you the entire thing again. But if you wanted to reduce the information to like shrink it down to just one single line, that you will see the usefulness of this when you start working so much on this particular project or something else, and there are a lot of commits. So you would see people tend to use Gitlog one line. In my experience, I actually use Gitlog one line more than the regular Gitlog, because it summarizes everything very nicely. It doesn't go into the nitty-gritties about the date and who was the author. It just shows me the small commit hash, and it shows me the changes that I have made. And so what questions do we have about Git version control, Git log one line, Git commit message, or guacamole recipes? I'm not an expert, but I could attempt to answer.
Oh, hello.
Hello.
So I've tried using this shell or GitHub before, but at least today I've understood something, maybe a few things. But the real question is there any problem it's trying to solve, or like what is it trying to simplify in terms of maybe how can I use it? Where do I use it? Like I know I understand it, but the question where I can use it is not the problem.
Okay, so you mean the real world application for something like Git?
Yeah, both GitHub and the shell.
Okay, so I'm going to try and give something of an answer. And so for Git I found to be really, really super useful. For like 3 years, I managed a website, and this is a personal example. I managed a website and I had teammates, some who were technical people who could contribute to the code of the website, and some who were not so technical. So Git was such an important part of our work, because if any errors were made when people attempted to help out with updating the website or updating information, it was so easy to revert back to a current stage. So for now, it's just like a file containing guacamole recipe, but it could be an actual database of people's health records. It could be a database of plant species, important information, and you don't want to leave that information in a way that it can easily be compromised and lost forever. It's in cases like that we really begin to see the usefulness of Git. And for Shell itself, we see the usefulness in helping us run chains of commands or to do repetitive tasks. So I'm trying to think of a real world example of where you might need. Oh yeah. So for my work, we have a shell script that looks at a Google Sheet every single week and takes information from that Google Sheet, publishes it directly on the website every single week. Imagine having a human being try to do that every week, to take the new information, sort it out, and then put it on the website. That might be cumbersome. They might forget. There might be errors. So the idea behind all of this is to try and make life easy for you by automating stuff that you can give to your shell to do. It's also, the idea is to do things in shorter time and to do them more efficiently with less errors. Humans are awesome and all, but there's a large margin of error when we try to do things without the help of external tools. And I find that when you start applying them to your own work, you begin to see the richness and usefulness of all of these tools. So I hope that helps in a way. Yes, Portmello. That's good.
Can I also add in my personal experience?
Yes, please.
It's 15 hours.
I was on a project which was based on molecular docking, in which we were trying to find chemicals from a plant which could potentially stop virus COVID-19. So it was mainly computational. So the way I see Shell could help me is that I was using the same thing, same method over and over again. So I think it can also help on that, and also on identifying which of the specific chemical has high binding affinity or strength to the target protein, or I can say to the protein of the virus. So in using Shell, we can better do the work faster and identify our chemicals of interest. Yeah. Thank you very much.
Thank you so much. And we've hit the hour and exceeded by 1 minute. Thank you all for being so engaged today. You made this a very fun experience. And I hope that for the rest of the workshop, you'll have more time to ask questions, participate, and yeah, learn some more. And James, thank you so much for being here today and helping out.
Thank you, Deborah. I think it's been amazing day. I'm sure everyone's enjoyed it and learned a lot. I think it's been really, really good. Thank you very, very much.
Thank you. Okay, do we have a final word for people before we send them off to go and have a long nap?
Yeah, you go and rest for a bit.
Alright.
You're not around tomorrow, Deborah, are you?
No, I'm
Deborah,
not.
how are you?
I'm good, thank you.
So what are you doing in Cape Town?
Oh, so I'm not in Cape Town, I'm in Nigeria. I'm a nurse and midwife here.
Okay, you're a nurse and midwife in Nigeria.
Yes, I am.
Where?
In Port Harcourt, Nigeria.
Okay. Okay, that's good. Thank you for helping out.
Of course, you're welcome. It's my pleasure. And
Yeah.
What are you using these skills for? I'm just curious.
As a nurse, what are you using it for? Let's ask you.
This is a fantastic question. So I've actually not up until this point used my technical or software skills in nursing. I've only ever used my software skills in software engineering for my job. But I'm hoping to marry the two of them together in like health informatics or something like this.
Okay, that's good.
Yeah.
Can I ask?
I think that will be quite interesting.
The best.
Yeah. Someone was about to ask a question.
I wanted to ask if we can have access to recordings for later practice on our own. Is it possible?
I'm not sure, and the person who is in the best place to answer, let's say, isn't on this call, but I will ask and have an answer ready for you tomorrow. Actually, James is going to have an answer ready for you tomorrow.
Thank you very much. I appreciate it.
Alrighty. Thank you all. Enjoy the rest of your day or night.
And we start again tomorrow morning, so we'll hopefully see everyone then.
Yes.
Thank you very much.
Yeah, thank
Thank
you,
you,
Trevor.
Deborah.
Thank you, Sylvester. Thank you, Nancy. Thank you, Dorcas. Thank you, Blessed. Thank you, Botimelo. Thank you, James. Bye.
Bye-bye.